Venus looks, at first glance, completely hostile to life. Its surface is hot enough to melt lead. Its clouds are made of concentrated sulfuric acid that destroys complex organic molecules. And the atmospheric pressure is about 92 times higher than that on Earth, strong enough to crush anything we recognize as living. Taken together, it seems like a total dead end, but that conclusion isn't as straightforward as it sounds. Start with temperature. Yes, the surface is extreme, but Venus isn't uniform. About 30 miles up, conditions change a lot. Temperatures drop to below 120 degrees Fahrenheit. Still hot, but comparable to a very hot day in places like Arizona or parts of India. Now, the sulfuric acid clouds. These are highly corrosive and reactive. Sulfuric acid breaks down most metals and organic material very quickly. Direct exposure would destroy familiar forms of life, but recent work from MIT suggests the chemistry in these clouds may not be as limiting as it seems. This comes down to how certain molecules behave. One example is cyclopentane, which forms a 5-membered ring structure somewhat similar to parts of DNA. In concentrated sulfuric acid, these ring structures remain stable. That matters. It shows that not all complex organic structures fall apart in this environment. Put simply, chemistry doesn't completely rule out life. Experiments back this up. Organic reactions can happen in sulfuric acid, producing things like amino acids and nucleic acid bases. More recent research goes further, asking whether more complex DNA-like systems could exist using different molecular building blocks. Cyclopentane-based structures appear stable enough to act as a kind of framework for genetic-like systems. Not DNA as we know it, but something that could play a similar role. Then there's pressure. Venus's surface sits under about 92 bars of CO2. To make that easier to picture, 1 millibar is roughly the pressure you feel holding a single penny. But since pressure is force spread over area, when scaled up to something the size of a human body, the force becomes enormous. 92 bars would feel like millions of pounds to you. Changing that kind of pressure would require planet-scale engineering. There are 3 main theoretical ideas. First, block some sunlight with large orbital shades to cool the planet, causing CO2 to condense or freeze, and reduce atmospheric pressure. Second, chemically lock CO2 into solid carbonates by reacting it with minerals like calcium or magnesium. Third, add hydrogen to convert CO2 into water and solid carbon. All of these are chemically possible, but far beyond current capabilities. None of this proves there is life on Venus. What it does is remove the idea that life there is impossible. Along with earlier signals like the debated detection of phosphine, it shifts Venus from a closed case to a place worth taking seriously.
Venus is often called Earth's evil twin. The thing is, this world once started off quite similar to our home planet. But later, something went wrong. These days, the 2 planets are relatively close and similar in size. But Venus's atmosphere is very different from that on our planet. All thanks to a runaway greenhouse effect that has been going on for a long time. The surface of Venus can get even hotter than the surface of Mercury, 864 degrees F. And the surface pressure feels as if you're more than half a mile underwater. The thick atmosphere presents its own challenges. Its clouds consist of sulfuric acid, which is used in lead-acid batteries as well as industrial cleaners. And if you decided to land on the planet, you'd have to survive atmospheric entry, with friction heating you up to 20,000 degrees F. Still, people have always wanted to explore this inhospitable world. And we can't but talk about the Venera program. During the 1970s and 1980s, several spacecraft studied Venus from orbit and from its hostile surface for an hour or so at a time. The 10 successful Venera landers provided us with most of the data we have today about the surface of this mysterious planet, including surface composition, direct measurements of atmospheric conditions, and sets of unique images. At the same time, Astronomers got their hands on these treasures only after a series of annoying failures. They started with Venera 1, launched in February 1961. Each consequent spacecraft was somehow improved and upgraded, but it still wasn't until the fifth group of Venus-bound space probes launched in 1967 that one of them, Venera 4, reached its target and sent data from Venus. Before that, Venera 2 and 3, launched in November 1965, were supposed to land on Venus, but both of them failed in transit. 11-foot-tall Venera 4 was a hefty thing. Its bottom lander was a bunch of instruments and a battery wrapped up in a pressure shell equipped with a parachute. This probe reached Venus in October 1967 and successfully launched the lander. The mother spaceship sent the probe flying over the planet, and it entered Venus's atmosphere. Temperatures were reaching 20,000 degrees F, and the entry force was as great as 450 G. It didn't prevent the onboard instruments from analyzing the atmosphere and sending back data. The first recorded temperature was 102 degrees F, and atmospheric pressure was similar to that on Earth. But the deeper the probe went, the higher the numbers became. 10 atmospheres, 20. They kept going up much higher than engineers had anticipated. 93 minutes into the mission, when the probe was still more than 16 miles above the surface of the planet, Venera 4 cracked open near its top and crashed. At the crash point, the measurements showed 22 atmospheres and 530 degrees F. Scientists realized that they needed a bigger spaceship. After some intense engineering, Venera 5 and Venera 6 saw the light of the day. Engineers did everything they could to make the landing probe stronger, but they were pressed for time. That's why Venera 5 and 6 were not fully prepared when they went on a mission. That's why Venera 5 transmitted data for a mere 53 minutes before succumbing to temperatures of 600 degrees F and pressures of 27 atmospheres. And Venera 6 lasted for 51 minutes. In any case now, the leaders of the project knew what it would take. 840 degrees F, 100 atmospheres, corrosive acids. They seemed to be prepared. They found new materials to build the probe. They got a hotter and stronger test chamber for the trials. They modified the parachute to make the lander fall faster so that the probe could spend as much time on the surface as possible. The lander was also designed in the shape of an egg and made of titanium, so its surface was smooth and had just a few ports, welds, and substructures. The insides were lined with a shock absorber and insulation layer. The chamber was also to pre-chill to freezing temperatures before entry. And Venera 7 was finally a success. It reached the planet in December 1970, separated from the mothership, and went down into the atmosphere. The probe transmitted data for 35 minutes, and things seemed smooth. But then, its chute melted, and the probe dropped like a rock, hitting the ground at 35 miles per hour and bouncing. Then, a second after the landing, the signal was abruptly cut. It looked like the probe crashed to bits. Shockingly, a few months later, while looking through all the data they managed to get, engineers rediscovered the signal. It was super weak and lost amidst the noise. Apparently, when Venera 7 bounced, it misaligned the antenna. The probe rested on its side, which weakened the signal to 1 or 3% of its initial strength. The probe kept transmitting data for 23 minutes. After that, the temperatures got too high and melted its shell. Venera 8, launched in 1972, had a similar design and experienced a similar fate. Venera 9 and 10 were a new generation of probes. They could send back black and white photos. It was actually the probe's main goal, to send the first ever photographic panorama from another planet. Venera 9 and 10 were 5 times heavier than their predecessors and weighed 5 tons at launch. The lander was 6.5 feet tall. It was basically a hermetically sealed titanium sphere that was supposed to hold the instruments. It was bolted with gold wire seals. Inside, there were shelves of beryllium and electric fans, whose main goal was to disperse heat to prevent instrument failure. On the bottom of the lander, there was a shock-absorbing ring. And at the top, There was a titanium ring that looked like a hat. It served as an aero brake. The parachute was supposed to detach at 30 miles above the surface, and the aero brake had to do the rest. In October 1975, Venera 9 and 10 arrived at Venus and landed as planned. Venera 9 was the first to land. It touched down on a slight slope, a volcanic crater or a hill, and kicked quite a bit of dust while landing. One of its two cameras succeeded in photographing and transmitting data, and soon scientists saw the first ever pictures of the surface of Venus. It was mostly sharp rocks, soil, and a distant horizon. The sun was slightly obscured by clouds that day. A gentle breeze was blowing. Overall, it was a pleasant morning. If you didn't pay attention to crushing pressure, almost completely waterless atmosphere, insanely high temperatures, and corrosive acids. Venera 10 landed in the same way a few days later, but the terrain it landed on was much more boring. Just a rolling plain with hardened pieces of magma. Both probes transmitted for 40 to 60 minutes until their orbiters went out of range. When it happened, the temperatures inside the probes were reaching 140 degrees F. The orbiters later burned up in the atmosphere after completing their mission. Venera 11 and 12 could have been a success, but a mysterious electric anomaly messed up with their cameras, so their trip was quickly forgotten. And Venera 13 and 14 entered the picture. They had improved scientific instruments and cameras that could take color images, and new heat-resistant technologies were used during the creation of these probes. Venera 13 arrived first and landed as planned. It took two photos, one black and white and the other in color. In the photos, one could see a surface of pebbled, loose soil and outcroppings of bedrock. It all looked pretty similar to the surface of the ocean. In the distance, there were rolling plateaus and an orange sky. The images taken later by Venera 14 showed a more weathered plain with less loose soil and fine-grained rocks. The two probes also sent back what they heard. It mostly sounded like a gently blowing wind with hints of distant rumbling. Could be Venus quakes. Venera 13 and 14 were the last landers to touch the surface of the planet. Venera 15 and 16 just flew around Venus, mapping its topography from orbit.
5, 4, 3, 2, 1.
Ah, Saturn. Incredible with its majestic rings and swirling clouds. But what would it be like to dive into it? NASA's Cassini tried that, and it turned out to be a wild trip. NASA's Cassini spacecraft was a probe that spent 13 years orbiting Saturn and gathering some incredible data. One of its major goals was to help us understand how come Saturn's atmosphere is so hot. The upper atmospheres of planets are always heated, duh. They're directly under the sun. The strange thing about Saturn is that gas giants are too far from the sun to get that kind of warmth. So Cassini didn't just observe the planet from outside. On September 15, 2017, it dove deep to the journey that would become the spacecraft's grand finale. Its last moments were spent inside Saturn's upper atmosphere, sending back priceless data as it slowly disintegrated. Now, these upper layers are no joke. The planet's horrifying magnetic field hums with energy, and powerful winds whip around at thousands of miles per hour. Cassini would pass through thick layers of clouds, hazy, pale gold, and muted, reflecting the sun's faint light. And these aren't cute, fluffy Earth-like clouds made of water vapor. This is a nightmare cocktail of hydrogen and helium. The probe ventured deeper, passing through the region where Saturn's iconic rings rain material onto the planet. Cassini discovered that this rain was more intense than anyone expected, more than 22,000 pounds of material per second. That's at a rate that Saturn's rings might not last forever. The planet's own gravity could eat them away completely someday, unless the rings get a sudden update. These are all tiny grains of ice and dust, caught in the planet's gravity, falling into the atmosphere like a relentless storm. The grains, mixed with water, methane, and even chemicals like propane and butane, slowly alter Saturn's atmospheric chemistry. It mixes with the particles in the planet's upper atmosphere, making them heavier and warming Saturn up. Unfortunately, this was too much for poor little Cassini. It was designed to be tough enough for the outer layers, but it burned up before it could descend into the terrifying deeper regions. In the more intense layers of Saturn's atmosphere, winds reach extreme speeds of over 1,100 miles per hour. The pressure becomes crushing, and the deeper you go, the more overwhelming it becomes. It would feel like entering an ocean of gas, one with no clear surface, where the sky gets darker, thicker, and more hostile as you descend. And at a certain point, complete darkness. Just you and the overwhelming mass of hydrogen gas pressing in from all sides. But Cassini's sacrifice was invaluable to scientists. The key data it sent us before the grand finale allowed scientists to map Saturn's upper atmosphere more completely than ever before. Cassini tracked bright stars, like those in Orion and Canis Major, as they passed behind the planet, measuring how their starlight shifted. This helped scientists to understand how dense and hot the atmosphere was. It left us some final pictures as well, though they're not as impressive as you might think. It was a monochrome shot taken from about 394,000 miles away, showing a dark portion of Saturn's night side, softly illuminated by the reflection of its own rings. NASA also posted a picture made by their own artists of what Cassini could have seen in its last moments. And of course, it gave us the answer to the big mystery of Saturn's heat. It's because of auroras. It turns out that due to the crazy magnetic field, the planet's cloud layers are sparked up by sudden bursts of auroras at the poles. They're like the northern lights on Earth, but far more intense. The gas giant's skies occasionally light up with radiant greens and blues. They're sparked by the interaction between solar winds and the charged particles from Saturn's moons. The hottest areas of Saturn were near these auroras. These light shows are powerful enough to heat the upper atmosphere, spreading warmth across the planet. Thanks to this added information, we discovered something important, not just about Saturn, but about all gas giants across our solar system and beyond. Meanwhile, the photos we have of Venus are much more dramatic. Venus is a bit closer to the Sun than Earth. It's often been called Earth's twin because of the similarities, like in size, mass, and composition. But don't be fooled. Beneath those thick clouds lies one of the most toxic environments in our solar system. Its surface is a nightmare, where temperatures soar to about 900 degrees Fahrenheit, hot enough to melt lead. The pressure on the planet is crushing as well, 92 times that of Earth's. That's like standing 3,000 feet under the ocean. We just couldn't resist taking some pictures. So, in the 1970s, scientists managed to land probes on this volcanic, unforgiving surface. And these missions were successful. They managed to send back the first photos of Venus and showed us incredible stuff. The first probe lasted only 23 minutes on the surface and then crushed down under this crazy pressure, winds, and heat. Both first and second probes captured black and white panoramas of a rocky hillside. On both, the second lens failed to eject. The horizon was flat, the ground strewn with jagged rocks, and the oppressive atmosphere pressed down like an invisible force. After lots of hurdles, we finally managed to look at colorful pictures from Venus in the 1980s. This spacecraft lasted more than 2 hours after extreme conditions. It's incredible that they managed to send us anything at all. Venus is a planet where metals melt, and where the atmosphere itself eats away the spacecraft. The photos it took showed that on Venus, the skies aren't blue, but an eerie yellow due to the thick clouds of sulfuric acid. NASA also has some computer simulations of what Venus's surface could look like, but these don't really convey the horror of actually being there. Perhaps it's time we look at Venus once more. There's so much we don't know about this fiery neighbor. Finally, we also tried to enter Jupiter's atmosphere in the 90s, and that's the hardest one on the list. NASA's Galileo missions probe was designed to dive into Jupiter. It was launched in 1989 and traveled millions of miles with a small entry probe on board. This tiny hero would face one of the most intense environments we've ever encountered in space. It was finally released on July 13, 1995. At that moment, the spacecraft was still 50 million miles away from Jupiter, So just to enter the atmosphere, it had to fall for months. And it finally did fall on December 7th, plunging headfirst into Jupiter's thick, swirling atmosphere. The probe slammed into Jupiter's skies at a staggering 106,000 miles per hour. That's fast enough to cross the United States from Los Angeles to New York in 90 seconds. The intense deceleration caused the probe to experience a horrifying gravity, 228 times stronger than the Earth's. It slowed down from supersonic speeds to just 100 miles. Wave ahead of it glowed as brightly as the sun itself. The temperature soared to 28,000 degrees Fahrenheit. And all this time, somehow, the probe was collecting data every second and sending it all to us. It gave us some critical information about Jupiter's mysterious atmosphere. For example, it turned out that Jupiter's upper atmosphere was drier than expected, less water vapor and fewer organic compounds than scientists thought. The probe also measured fierce winds of up to 0.5 mile per second. And surprisingly, it didn't see that much lightning, even though we thought these are never-ending on Jupiter. One of the probe's biggest surprises was the discovery that Jupiter's atmosphere contained less helium than we thought. It also revealed a horrifying radiation belt about 30,000 miles above Jupiter's clouds. It's like intense radiation encircles the planet like a cosmic shield. The poor little guy managed to survive for 58 minutes. It eventually succumbed to immense pressure. Meanwhile, the Galileo orbiter continued its mission, becoming the first spacecraft to orbit Jupiter. Venus has more volcanoes than any other planet in the solar system, more than 1,600. And a day on Venus, measured by how long it takes to rotate once on its axis, takes longer than the time it takes to complete a full orbit of the Sun. Wow! And that's just Monday. An extreme greenhouse effect warms the planet's surface up to 870 degrees Fahrenheit, hot enough to melt lead. Winds there reach the speed of 450 miles per hour in the middle cloud layer, faster than the speediest tornadoes on our planet. The pressure on Venus's surface is 90 times higher than that at sea level on Earth. What a great place for a vacation, huh? And recently, this incredible place has become even more intriguing. In the toxic Venusian atmosphere, there's something that might mean the existence of life. Unfortunately, scientists haven't had a chance to collect any microbe specimens or snap any pictures of life there. But they've discovered a chemical called phosphine, and it's a big deal.
If it's not some previously unknown chemistry that produces the gas, then there must be a kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any normal life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially.
The weirdest thing is that phosphine isn't supposed to be in Venus's atmosphere at all. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, the famous gas giants, but on Venus? Totally unexpected. There's no way phosphine can be produced naturally on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere. But it's not nearly enough to explain what the astronomers have observed. It would only make 1/10,000th of the phosphine the telescope saw.
But let's start from the very beginning. In 2017, a group of scientists led by Jane Greaves from Cardiff University started to use the James Clerk Maxwell Radio Telescope in Hawaii. That's a mouthful. The main idea was to search for phosphine gas. It would be a sign of life on Venus. When the data came back and the researchers analyzed it, they were shocked. The phosphine signal was powerful. The team checked the results several times. They wanted to make sure no other substance mimicked the presence of phosphine gas.
So now, does it mean there's life on Venus? Well, not necessarily. If this gas is created by some mysterious organisms, it's a big question how they survive on Venus. On our planet, some microbes can thrive in the environments with the acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid. And even though they have a rather pleasant temperature of 86 degrees Fahrenheit, these clouds contain more than 90% of sulfuric acid. DNA, amino acids, proteins, life components on Earth would be dissolved there in the blink of an eye. The surface of the planet is too hot for any kind of complex molecules to make up life. The Venusian atmosphere is almost 50 times as dry as the driest place on our home planet. There's a theory that microbes might hide in scarce water droplets floating in the atmosphere, but it hasn't been proved yet.
Right now, the research team's waiting for more telescope time. They're going to look for other gases associated with life. But even if they find more evidence, life forms on Venus will be made up of building blocks absolutely different than those on Earth. Or they might be protected by a sulfuric acid-resistant shell. It can be made of such substances as sulfur, wax, graphite, or something else we can't imagine.
Of course, some experts question the idea of life on Venus. They think the gas might be produced during some geologic or atmospheric processes happening on the planet. But the supporters of both theories agree on one thing: the discovery is extraordinary. Interestingly, astronomers have always tried to find signs of life on giant planets' icy moons, or even closer, on Mars. But they've never seriously considered Venus. If additional telescope observations and future space missions confirm that phosphine is produced by living organisms, we can be in for a bunch of exciting surprises. Then people would know of a planet with an alien biosphere, well, alien to us, and this planet would be just next door to Earth. Now, speaking of visiting Venus, though, would it be possible for people to land on this planet? After all, robots are already tooling around the red planet surface. On the pro side, Venus is closer to Earth than Mars, but it also has much harsher conditions. The planet is hotter than Mercury, even though Venus is almost double the distance from the Sun. The temperatures are higher than the melting point of many metals, and some of them, like lead or bismuth, can fall as snow on the highest mountain peaks. If you set foot on the planet, you'll find nothing but barren rock. Giant basaltic plains are littered with volcanoes and mountains. In some places, the surface melts because of the heat underneath. After it releases some of it, the rock solidifies again.
If people ever go to this planet, they will most likely build floating cities in the clouds of Venus's atmosphere. At about 31 miles above the surface, the conditions, like the pressure and gravity, are similar to those on Earth. The temperature is rather manageable too, at around 167 degrees Fahrenheit. Think Death Valley, California on a really hot day. The atmospheric pressure is half of what we have at sea level on our planet. If you went outside, you'd be fine without a pressure suit. The pressure you'd feel would be the same as at the top of Mount Kilimanjaro. Plus, this colony would be protected from the sun's radiation better than one on Mars.
If the atmosphere was the mission's final destination, landing a spacecraft, or rather making it hover in the air, would look very different. The idea is to use an airship in the upper atmosphere for long periods of time. The airship, wrapped in an aeroshell, would enter the planet's atmosphere at a speed of 24,000 feet per second. In the next 7 minutes, its speed would drop to around 1,500 feet per second. After that, a huge parachute would open. It would slow the spacecraft down even more, and then things would get a bit hectic. The aeroshell, not needed anymore, would drop away. The airship would then inflate itself, all the while hurtling through the atmosphere toward the planet's surface. Its speed would be at least 330 feet per second. It would get larger and larger, and its drag and lift would increase. Soon, the parachute wouldn't be needed anymore. The crew would get rid of it, and the airship would fill with air completely. If everything went as planned, it would stop 30 miles above Venus's surface. After that, the airship would travel around the planet. It would be moved by the wind, which can reach a speed of 220 miles per hour at the top of the cloud layer. If you decided to move closer to the surface, though, you'd have to be extremely careful. The wind in the middle layer can get twice faster. The airship could be filled with a breathable mixture of hydrogen and oxygen gases. Such a combination would be less dense than the Venusian atmosphere. It would provide the needed buoyancy, to stay up there. Venus is famous for its super dense clouds. These clouds make the planet shine bright enough to be seen from Earth. Venus reflects more than 75% of the light that comes from the Sun. This reflective cloud layer exists thanks to a haze of sulfuric acid droplets in the atmosphere, and they gather exactly at the height where the airship would float. Luckily, people already have a method to overcome the problem of acidity. A few materials, for example Teflon and some types of plastic, have an amazing acidic resistance. They could protect the outsides of the ship. So, let's say you needed to work on a platform outside. Then you'd be able to do it, wearing only a chemical hazard suit and carrying necessary oxygen supply. Ooh, sounds like fun, huh? Yeah, me neither. So, Venus and Earth are so different that a foolish question like, what's longer, a day or a year, that makes absolutely no sense on Earth, totally makes sense on Venus. A day on Venus is indeed longer than a year. If we put it into Earth's perspective, a day on Venus would equal 243 Earth days, while a year would only last 225 days. So it's like your birthday is every day. Venus is often nicknamed Earth's evil twin. Their differences are so stark, you'd think they're from different galaxies altogether. Just to give you an idea of how far apart they are, if the day-to-year ratio wasn't enough, the Earth rises in the west on Venus but sets in the east. These days, one of the very few similarities between these two is their size. But try to imagine a time when Venus and Earth were like peas in a pod, besties since the beginning of the solar system. Venus used to be the life of the party. NASA scientists think Venus might have even hosted a liquid water ocean and surface temperatures that could have welcomed life for up to 2 billion years. But modern-day Venus is a different story. We're talking extreme temperatures and a thick carbon dioxide atmosphere. So, what led to this cosmic makeover? Size, location, and attitude. I mean that the distance from the Sun and internal heat played a huge role in shaping Venus and Earth's destinies. By the way, there used to be 3 siblings that could have hosted life: Venus, Earth, and Mars. Now imagine 3 cupcakes in an oven. Once they were fully baked, they were taken out of the oven. One of them was put in front of an open window in the middle of winter. Another was carefully placed on a table and covered with a nice clean kitchen towel. And the last one was accidentally forgotten and left in the oven. Oops. Mars, Earth, and Venus are like those cupcakes. Mars got too cold and not welcoming. Earth is still nice and warm and well protected from all the unpleasant things, just like the towel protects that lucky cupcake. And Venus got scorching hot and impossible to consume. In terms of development, Earth took the slow and steady route, maintaining its oceans, stable atmosphere, and biodiversity. Venus, on the other hand, cranked up the temperature, evaporated its oceans, and went all in with greenhouse gases. As a result, we have a planet where you'll melt faster than a snowman in July. Mars, on the contrary, will turn you into an ice popsicle within seconds. But chances are, it might have been pretty hospitable at some point. Some scientists believe that Mars used to be covered with flowing rivers and lakes and had no water shortages. Even today, Mars still has an ocean called Oceanus Borealis, or rather, the remains of what once used to be an ocean. It lost nearly all its water over time. Now, the sources of water on Mars include polar ice caps and minerals and rocks. According to estimates, only 1% of all that water evaporated, while 99% is still locked in the red planet. Ice polar caps are pretty simple to understand, as we have the same thing on Earth. But rocks containing water? Simple. There are at least 4 types of hydrous minerals on Mars. There are hydrous clays made of silicon oxygen, and the cool thing about them is that they can even contain magnesium and iron, which are sulfur-based hydrous sulfates. Now, don't you? I know you thought of the smell of rotten eggs, but it's typical of hydrogen sulfur and not just sulfur. These minerals have water incorporated right into their chemical formulas. There's also hydrous silica, which has water locked in its formula too. Scientists have experimented with growing plants using Martian-like conditions and found success with alfalfa. Harvesting alfalfa also helped improve the growth of other crops like turnips and lettuce. While water may be available on the red planet, the air on Mars is mostly carbon dioxide. On the bright side, and the Mars Oxygen In Situ Resource Utilization Experiment, the Mars Oxy, can produce oxygen on Mars, which could be crucial for future missions. As for energy sources on Mars, solar, wind, and geothermal energy are a few promising options. Solar power is less effective on Mars due to weaker sunlight and dust storms. But wind power and geothermal energy could serve as reliable alternatives. With these sources in place, humans could potentially sustain life on Mars. But let's get back to comparing our sibling planets. While both Mars and Earth have moons, and Mars even has 2 of them, Venus has 0, just like Mercury. Due to its proximity to the Sun and the star's gravitational pull, Mercury lacks the ability to retain its own moon. The likelihood of any moon orbiting Mercury either colliding with the planet or being drawn into the orbit of the Sun is high. That's all clear and understandable. But the absence of moons around Venus remains an unsolved puzzle for scientists. Despite Venus's scorching hot temperatures, scientists think that even today, it might not be as hostile to life as we once thought. A recent MIT study found 19 amino acids surviving in a Venus-like solution for the whole month. Yep, some like it hot. Also, Rocket Lab and the Massachusetts Institute of Technology are teaming up to send an uncrewed spacecraft, Venus Life Finder, on a mission to Venus. This spacecraft will search for signs of life in the Venusian atmosphere using a special instrument called an autofluorescing nephelometer. And no, I didn't make that up. Originally set to launch in 2023, the mission is now pushed back to December 2024 with arrival at Venus in May 2025. The goal of the mission is to discover organic compounds in Venus's atmosphere, which could point to the possibility of habitable conditions in the cloud layer. The spacecraft is designed with a Photon Explorer cruise stage and a compact atmospheric probe equipped with that nephelometer thingy. The small probe will descend through the Venusian atmosphere, collecting data on cloud particles and organic compounds. In 2020, scientists made a big announcement about finding phosphine on Venus, a compound that could be linked to life. While they're still working on confirming this, using information from telescopes or even past missions, there might be evidence hidden in old NASA data received from Venus that could shed more light on the discovery. The potential presence of phosphine on Venus has stirred excitement and caution among scientists. To make sure, they need more data from telescopes or new space missions. If they find this gas, it might mean there is some form of life producing it in the planet's clouds. This discovery would be a huge step toward understanding Venus better. Some experts think that sending probes to Venus to directly detect phosphine would be the most effective way to confirm its presence. An 80s NASA mission may have already detected phosphine, but scientists back then didn't realize it. Now, this data is being re-evaluated to uncover any overlooked evidence of the presence of the gas. This could also suggest that the compound has been in Venus's atmosphere for decades, raising questions about its source. But not everyone is convinced of this interpretation, which evokes a debate among scientists about the true nature of the detected gases. Old data from other missions may also hold clues about phosphate on Venus. While new spacecraft are going to explore the planet, it's possible that the key to unlocking this mystery lies in decades-old mission records. In total, there have been 46 space missions to Venus, including some flybys where gravity lent a helping hand. The last time we successfully landed a spacecraft on Venus was way back in June 1985 as part of the Vega 2 mission. So, let's see what Venus Life Finder will discover. Oh man, the Sun did it again! It just blasted a huge cloud of plasma into space. This time, it was one of the fastest and most powerful eruptions of this solar cycle. It was so strong that the shockwave hit Venus, our next-door neighbor. That's when scientists got worried and started asking a scary question. Could Earth be next? Well, let's just cut to the chase. If your GPS and internet have been working fine over the last few weeks, and your city hasn't had any big blackouts lately, you already know the answer. No, that powerful blast didn't hit Earth. Or at least we didn't feel any real effects from it, because this event happened in October 21, 2025, and if our planet had been in its path, we would have felt the effects only a few days after that date. You see, we're talking about coronal mass ejections, or CMEs. From time to time, the Sun throws a giant cloud of superhot plasma into space, straight from its outer layer, the corona. Think of plasma as a superheated gas. It's what the Sun is made of, and it's full of tiny charged particles, positive ions and negative electrons. These outbursts happen because the Sun's magnetic field is always moving and twisting. Sometimes the magnetic lines get tangled up, then suddenly snap and reset. This process is known as a magnetic reconnection. And when that happens, boom, the Sun launches a CME. A single coronal mass ejection can throw billions of tons of material into the solar system in one shot. And it can create a shock wave. That shock wave can speed up charged particles, which raises the chance of a radiation storm. And if a planet is in the way, yeah, that can be trouble. The tricky part is that CMEs are pretty unpredictable. They can blast out in different directions, and they don't all move at the same speed. The fastest ones race through space at millions of miles per hour. If one is aimed at Earth, it can get here in as little as 15 hours. Slowest ones can take days to get here, but even then, it's usually somewhere between 1 and 5 days. It's not like months. Since this big blast happened a while ago, it's safe to say that, well, we're safe. And honestly, even if it had hit Earth, we'd probably be safe anyway. Sure, a strong CME can mess with satellites, disrupt radio and internet signals, and even knock out power grids for a while. But it's not the kind of thing that ends the world or wipes out humanity. So, take a breath. Even a really powerful solar eruption isn't going to destroy Earth. Unfortunately, we can't say the same thing about Venus. CMEs hitting our neighboring planet are actually one of the reasons Venus can't support life, at least not what we consider life. But don't worry, we'll get to that part later. First, let's dive into this recent solar outburst and what made it so extreme. This one came from the far side of the Sun, the side we can't see from Earth, and it came from an especially active sunspot area called 4246. This is a new, huge, messy sunspot that's been responsible for the latest round of solar storms headed our way. The big blast happened right after that region rotated past the Sun's western edge, so it was out of view from Earth and from most weather satellites. Thankfully, the event was caught by an instrument on a NOAA satellite called CCOR-1. Think of it like a special camera designed to spot big solar blasts even when they happen on the far side of the Sun. That's why it's strategically placed so high above Earth, and it orbits about 22,000 miles over the equator. The CCOR-1 manages to capture those images by blocking the Sun's blinding surface, so it can see the faint glow around it and track huge plasma clouds as they spread out into space. Now, let's talk about speed. NASA estimates that the CME in October was moving at about 820 miles per second. But the first radio signal suggested it might have been even faster, close to 1,537 miles per second. Trust me, that's crazy fast for a coronal mass ejection. To put that in perspective, only a handful of blasts in modern history have been quicker. One famous example happened in 2017 during an X-class flare rated around X8. So according to NASA, X-class means the strongest kind of solar flare. The number tells you how strong it is. An X1 is the baseline, an X2 is twice as strong, an X3 is 3 times as strong, and so on. So yeah, an X8 flare is something huge. Back on Earth, that 2017 event did mess a bit with high-frequency radio signals for a while. But for us, that was pretty much it. Mars was a different story. When the same event hit the red planet, it heated the upper atmosphere in an uneven way. In the hottest areas, scientists saw the top two layers, the thermosphere and the ionosphere, start interacting more than usual because of the blast. And that had a real effect. Oxygen began escaping into space much faster than normal. In other words, that brief event made Mars lose part of its atmosphere at a higher rate. Now, when we talk about this recent burst, the story is kind of similar, but with a twist. This time, Mars wasn't the main target, Venus was. The planet was sitting right in the path of the solar burst. So when the blast hit, Venus got slammed with a storm of charged particles. Now you might be wondering, why is it a bigger problem when a solar eruption hits planets like Venus or Mars, but not as big of a deal for us here on Earth? Well, it's because of Earth's magnetic field. So big blasts from the sun can mess with the atmosphere around a planet. But on Earth, a lot of that impact gets blocked by a natural magnetic bubble called the magnetosphere. Good thing, huh? Here's how it works. A wave of plasma comes from the sun and slams into the magnetosphere, the region around Earth controlled by our magnetic field. That magnetic field pushes most of the charged particles away, kind of like a shield, but not all of them. Some particles still sneak through and crash into the upper atmosphere. When that happens, we can get geomagnetic storms. These storms create amazing auroras. They can also mess with satellites and communication networks, like we talked about earlier. But some planets, like Venus, don't have a strong magnetic field like Earth does, and that can be bad news. Because when a CME wave reaches Venus, the charged particles crash straight into the atmosphere and, over time, slowly peel parts of it away. Now here's a real example. On December 19, 2006, the Sun released a small, slow CME. Even though it wasn't moving fast, it was still strong enough to do damage. About 4 days later, it reached Venus and ripped away a large amount of oxygen from the planet's atmosphere, sending it off into space for good. Or bad. And this is actually one of the big reasons why planets like Venus are uninhabitable. Without a strong magnetic field, CMAs can slowly strip away their atmosphere, blast the surface with dangerous radiation, and create brutal space weather conditions. Venus is a perfect example. It is the hottest planet in our solar system, being 100 times hotter than Earth. Its atmosphere is insanely thick, and the pressure over there is insane, so much so that the longest any spacecraft has survived on its surface before being crushed is a little over 2 hours. Scientists think that getting hit by solar eruptions without a proper magnetosphere to protect it helped push Venus toward this extreme world. And by studying what happens to planets like Venus, we can learn something bigger: how important a magnetic shield might be for life on other worlds we find outside our solar system. So, planets with two suns, like Tatooine from Star Wars, used to sound like pure fantasy. For decades, scientists believed these systems were too unstable to exist. Two stars tugging at a planet should fling it into space or drop it into one of the suns. Except, it turns out that nature didn't get the memo. Astronomers have found a planet calmly orbiting two stars like it's no big deal. This planet lives closer to its two parent stars than any other directly imaged planet in a binary star system astronomers have ever seen. Now, direct imaging means they saw the planet's light, not just its shadow. The whole system sits about 446 light-years away, so the light we see from it today left before humans ever built modern cities. This space monster is roughly 6 times the mass of Jupiter. And even more surprising, the planet is only about 13 million years old. That sounds ancient until you zoom out a little. Earth is about 4.6 billion years old, which makes this planet basically a newborn in cosmic terms. The two suns of this monster orbit each other incredibly fast and complete a full loop in just 18 Earth days. That means their gravity constantly shifts, yanking space around them like a cosmic washing machine. Even so, the planet stays locked in its path, so it takes it 300 Earth years to finish a single orbit. So nobody fully understands how this planet formed in the first place. When two stars orbit each other this closely, their gravity usually tears apart planet-forming material before anything big can take shape. Scientists have only found a few dozen planets like this so far, and that's nowhere near enough to piece together the full story. To solve the mystery, they need more data. Now, another cool find that still needs more research is a planet so stretched by gravity that it looks like a lemon, not a sphere. This planet is nothing like the calm blue and green worlds we see in space movies. It orbits a pulsar, which is basically a star's corpse. When a massive star expires, it collapses into an ultra-dense object that spins insanely fast and blasts radiation like a cosmic lighthouse. Being near one of those means game over for anything solid. And yet, this planet hangs on, barely. The gravity stretches it, pulling harder on the side facing the pulsar than the far side, like cosmic taffy. And here's where it gets extra unsettling. When scientists analyzed this planet's atmosphere, they didn't find water or oxygen. They found helium and pure carbon. No clouds, no oceans, no chance of life. According to everything we know about planet formation, this world shouldn't exist at all. So it might not be a planet in the normal sense. It could be the exposed core of a star that got shredded, leaving behind something stuck between planet and stellar corpse. That's a pretty scary trend. The line between planets and stars keeps getting blurry. And speaking of scary, meet this guy. This system lives around two red dwarf stars. These two stars orbit each other at a distance similar to how far Jupiter sits from the Sun. Scientists found two Earth-sized planets and a third possible one squeezed right up next to the stars. One planet completes a full year in just over 2 days. Another takes about 3.5 days. The candidate planet orbits even faster. To put that in perspective, these planets sit less than 2 million miles from their star. The Moon sits about 250,000 miles from Earth. So yeah, these worlds are close. When they combined data from space and ground-based telescopes, astronomers realized they were staring at something totally new: planets that transit or pass in front of both stars. Most planets in double-star systems orbit only one star, and this setup shouldn't last long according to the rules of physics. But these planets exist anyway, calmly breaking the rules. So this guy proves that planet formation works in ways we still don't fully understand, and space clearly enjoys messing with our expectations. Now, let's crank up the horror a notch. Astronomers made the first ever 3D map of a planet outside our solar system. And not just any planet. This one is so hot it literally tears water molecules apart. As the planet moved behind its star, the James Webb watched tiny changes in the star's light at different colors or wavelengths. Some colors get absorbed by water vapor, others don't. By stacking all that info together, scientists figured out temperatures at different heights and locations in the planet's atmosphere. And that's how they learned that parts of its atmosphere heat up to nearly 5,000 degrees Fahrenheit, hotter than molten lava. This superhot planet sits about 400 light-years away and weighs around 10 times as much as Jupiter. It races around its star in just 23 hours. 1 year there is basically a day. And because it's so close, the temperatures get so high. Winds try to move heat around, but they totally fail. WASP-18b's atmosphere barely has any water and instead overflows with carbon monoxide. Astronomers once believed water should be common in giant planet atmospheres. This world proves water is optional, not guaranteed. Now, magma worlds are another perfect proof of that. There's a huge group of planets called sub-Neptunes, planets bigger than Earth but smaller than Neptune. For a while, some scientists hoped these worlds were Haitian planets, covered in deep oceans of water or ice, wrapped in thick atmospheres. One famous example was K2-18. Its atmosphere showed methane and carbon dioxide, but almost no ammonia. But as it turned out, lava dissolves ammonia too, so the missing ammonia doesn't prove water at all. It could just mean the planet has a global ocean of magma instead. The researchers modeled how these planets heat up, cool down, and evolve over time. They asked a simple question: do these planets ever cool enough to stop being lava worlds? And the answer was almost never. When they tested thousands of known sub-Neptunes, they say almost all of them are likely lava worlds, not water worlds. In simple terms, these planets don't breathe water vapor, they breathe rock vapor. Their atmospheres come from magma boiling, not oceans evaporating. And that changes everything. Many worlds we once labeled maybe habitable turn into hellscapes the moment you run the numbers honestly. And that means space isn't hiding Earth clones, but mass-producing furnaces and other sorts of monsters. Take this bad boy, for instance. It sits only about 64 light-years away, which is uncomfortably close in cosmic terms, and it's the nearest hot Jupiter to Earth. From afar, it looks stunning, a smooth, deep blue marble floating peacefully in space. But that color hides something absolutely brutal. On this planet, it rains glass, sideways. Winds scream across the atmosphere at around 5,400 miles per hour, fast enough to shred anything instantly. The blue color comes from tiny particles of silicate, the stuff glass is made of, floating in the air. The planet's surface temperature hits about 2,400 degrees Fahrenheit, hot enough to melt rock. That heat turns those silicates into microscopic shards of glass that whip around the planet like a worldwide sandblaster. Standing there wouldn't hurt. You wouldn't exist long enough to ever feel it. And then there's the darkest planet ever found. It reflects less than 1% of the light that hits it. It's darker than coal, darker than black paint. Light just disappears into it. Not all planets even bother with stars at all. Astronomers have found rogue planets, worlds kicked out of their solar systems. These lonely planets drift through space in total darkness, frozen and untethered, with no sunrise ever again. Now, all of this shows us that our universe isn't designed for life. Life survives despite the universe, not because of it. Earth isn't typical, it's lucky. We're only at the beginning of this discovery era. Every year, new telescopes sharpen the picture, and every year, the picture gets stranger. The more clearly we see the universe, the less it resembles our imagination. And that's the most unsettling truth of all. Now, if Earth were the size of a nickel, Neptune would be about as big as a baseball. That's impressive, but it's nothing compared to the giant ninth planet that might be hiding out there. Now, our Planet 9's discovery saga might have finally come to an end. Turns out, the problem wasn't where we were looking, but how. And researchers might have just made the biggest solar system discovery in decades. You see, the idea of finding a planet beyond Neptune has been around for years now. I know, back in school, you probably learned that the ninth planet was Pluto. But forget about Pluto. It's been demoted to a less fancy category since 2006. What I'm talking about is the Planet 9, a hypothetical giant planet that could be our cosmic neighbor. We've never actually seen it, but scientists are pretty sure it's out there somewhere, hiding in the outer solar system. To explain why they think that, we need a sheet of paper. Hey, here's one. We place a coin on it, and suddenly, it starts to move. Unless we're talking about some kind of superpower, there's no way this coin is moving on its own, right? So, you figure someone must be on the other side, holding a magnet and moving it around. You can't see the magnet, but it explains why the coin is moving. That's kind of what's happening with Planet 9. We can't see it, we can't prove it, yet, but its existence could explain the strange movements we see out there in space. For example, the planets in our solar system orbit on a flat plane that's tilted about 6 degrees relative to the Sun. But why 6 degrees? Well, no one really knows for sure. Some scientists think those orbits might be slightly tilted because of the pull of a ninth planet. Its existence could also explain the unusual paths of smaller objects in the distant Kuiper Belt, a region full of icy debris that stretches far beyond Neptune's orbit. Back in 2016, researchers from Caltech published a study about Planet 9. They suggested it could have a mass about 10 times that of Earth and follow a highly elongated path. That's a scientific way of saying it takes forever to make one trip around the Sun. Because of that, it would be located in the outer solar system, far, far away. It would orbit the Sun about 20 to 30 times farther out than our most distant planet, Neptune. According to scientists, Planet 9 would take up to 20,000 Earth years to complete just one full orbit around the Sun. Since it's crazy far out there, it's almost impossible to see it. So, as cool as this hypothesis sounds, we've never found solid evidence that Planet 9 actually exists. But we might be pretty close. In May 2025, a team at National Tsinghua University might have made one of the most exciting solar system discoveries ever. Alright, so there's a hypothesis that Planet 9 hasn't been discovered yet because we haven't been using the right method. This new study raises an interesting question. What if Planet 9 actually looks brighter in infrared light than it does in visible light? Let me explain. Scientists have been trying to spot Planet 9 by its reflected light. But here's the problem. To spot it in visible wavelengths, sunlight would have to travel all the way out to Planet 9, bounce off its surface, and then travel all the way back to Earth. If a Neptune-sized planet were about 10 times farther away than Neptune, it would look about 10,000 times fainter. But a planet's own thermal radiation, its heat, only has to make a one-way trip. So in infrared light, Planet 9 would only be about 100 times fainter. That's why it makes more sense to look for it using space-based infrared telescopes. And that's the idea behind this new study. The team started digging through archives, searching for old infrared sky survey data, and they pulled it from two main sources. First, IRIS, a satellite launched in the 80s that scanned the sky for almost a year. Then, the Japanese satellite Akari, another infrared observatory that operated between 2006 and 2011. So basically, they compared objects that showed up in IRIS database and noticed which ones had moved by the time Akari took its observations. And by doing that, the researchers found something incredible, an object that might just be our long-lost ninth planet. Because if something moves, it could be a planet orbiting the Sun, right? And yeah, they did find some celestial objects showing tiny movements. But before jumping to conclusions, they had to rule out the parallax effect. And that's something really important when we're talking about solar system discoveries. To explain it, I need you to do something. Hold one finger in front of your face. Close one eye, and now switch. Your finger seems to move a tiny bit, right? That's because you're looking at it from a slightly different angle, from one eyeball to the other. The same thing happens when we look out into space from Earth. Since our planet orbits the Sun, our view of very distant objects shifts just a little. That effect is called parallax. My point is, because of this effect, Planet 9 would appear to move across the sky as Earth goes around the Sun. On any given day, it might seem to be in one spot, but 6 months later, when Earth is on the opposite side of the Sun, it would look like it shifted. 6 months after that, it would seem to move back again. Scientists had to account for parallax. Actually, they had to remove its effects. So the team looked at images of the sky taken on the same date every year. Because on that same date, Earth is always in the same spot in its orbit. That means if Planet 9 is real, it would show up in the same place in those images every year. No fake wiggle from parallax, just its real position. This careful search led them to a single object, a tiny dot in the infrared data. This strange little spot had moved slightly along its orbit around the Sun over the 23 years between Iris and Akari. Wait, could that be it? Did astronomers just confirm a hidden planet? Well, maybe. But don't get too excited. The data we have on its motion over that time is not enough to figure out its full orbit. So, for now, we still can't say for sure if this mysterious object is really Planet 9. It's definitely a strong candidate, though. Based on how bright the object appears, the team estimates it could be pretty massive, and that came as a big surprise. You see, previous NASA research ruled out any Jupiter-sized or Saturn-sized planets hiding out there, but a smaller world would have gone undetected. So the scientists were looking for something just a bit bigger than Earth. But it turns out this mysterious planet might be more massive than Neptune. Now that they've discovered Planet 9, supposedly at least, the plan is to keep tracking it and collecting new data. But don't think the road ahead will be easy. Because since the Akari satellite spotted it for the first time, that object didn't just sit still. It's been moving slowly through space ever since. So now scientists need to use regular telescopes on Earth to look for it again. And here's the tricky part. They're not exactly sure where it moved to, so they have to search a pretty big patch of the sky. And so far, no matching object has been found. Whether this really turns out to be the Planet 9 discovery or not, only time will tell. For now, its existence is still up for debate. But with powerful new technology on the way, like NASA's Nancy Grace Roman Space Telescope, astronomers are more determined than ever to uncover the truth. And if Planet 9 really is out there, hiding in the cold, dark edges of our solar system, it's running out of places to hide.
These days, you're better off boarding a plane if you want to travel from New York to London. But what if I told you there was a time when these two cities were actually on the same continent? Well, the explanation is a bit more complex. For starters, back then, these two cities didn't even exist at all. But the tectonic plates they sit on today were a lot closer. Nearly 200 million years ago, all of the continents on our planet connected, making up one large supercontinent. This enormous piece of land was surrounded by one single ocean. We call this huge continent Pangaea these days. Some parts of this continent broke apart and shifted away from each other for our maps to reach their current configuration. There's even a nice experiment you can conduct to test this theory. Find a map online and print it on a piece of paper. After that, simply cut out all of the continents. Once you start playing around with them, you'll soon notice they all seem to fit together, like pieces from a puzzle. Probably the most striking thing you'll see is how South America perfectly fits Africa. What's even more fascinating is that this isn't the first time in our planet's history that supercontinents have been formed and then broken apart. Scientists have figured out that this happened at least 3 times before. And if we consider our planet's age, 4.5 billion years, the last 200 million is closer to the blink of an eye. So how did scientists figure out that continents move? Apart from the aspect of today's continents, they also looked at identical rocks, which have been found on different continents. They looked like they formed from the same minerals and under the same weather conditions. Some other secret helpers? Well, dinosaurs. Fossils from the same species have been stumbled upon in both South America and Africa. This particular dinosaur, named Mesosaurus, is said to have lived on our planet way before the continents drifted apart. It's hard to imagine how life on Earth must have been with one single continent. For starters, the climate must have been very different. That's because the mid-portion of the land would have probably been bone dry, having little to no source of water. More so, it was most likely hidden away behind many mountain chains. These would have acted as a barrier against moisture and rainfall too. However, geologists have also studied coal deposits from the United States and Europe. These seem to show that at least a part of the ancient supercontinent, which was close to the equator, must have been an amazing tropical rainforest, just like those we can find in the Amazonian jungle today. Coal appears when remnants of plants and animals get stuck into swampy water. If enough pressure is applied by the water, the substance is first turned into peat, then into coal. Our planet existed in this continental configuration for over 100 million years, and during this time, there was a lot of life on Earth already thriving. Hey, it was a great time to be an insect. Critters like beetles and dragonflies flourished. During the same time period, the Earth was roamed by the predecessor of all mammals, the synapsid. Life in Pangaea was severely hit during one not-so-great period. It's believed that a comet or asteroid landed on the surface of the Earth about 251 million years ago. The asteroid or comet theory seems to fit pretty well, because 90% of all marine animals and 70% of the creatures living on land disappeared all of a sudden. The comet might not have been the only reason for the mass extinction. At the same time, there was also some important volcanic activity happening in northern Asia, which might have disrupted life on Earth. We may not notice it, But continents do continue moving as we speak. This configuration we now see with the help of satellite imagery will surely not be the last. Australia, for example, is slowly moving towards Asia. But the most important proof that our continents are still shifting is the eastern portion of Africa. This area is simply breaking off from the rest of the land. To witness this, you'll have to travel to one of the hottest places on our planet. But if you get to this piece of land on the eastern part of the African continent, you might sit on top of the exact spot that, soon enough, will be split in two by water. Underneath this region, 3 tectonic plates are slowly drifting apart. If the data is correct, in the far future, Africa will be split in 2, and between its 2 regions, a new ocean will arise. To support this theory, scientists have been closely studying a 35-mile-long crack in the Ethiopian desert for years. For this new ocean to form, it's estimated that 5 to 10 million years need to pass. Since our planet's crust is made out of multiple tectonic plates that are constantly moving, it's the perfect place to study this process. These plates are all irregularly shaped, and they are always mashing against, sliding under, or over each other. Those 3 tectonic plates found under the desert are also moving at different speeds. One of them, called the Arabian Plate, is sliding away from Africa at a speed of about 1 inch per year. The other 2 plates are moving a bit slower, somewhere between ½ an inch to 0.2 inches each year. More so, as these movements happen, material from deep inside Earth climbs to the surface and forms an oceanic crust at the edges. All this movement does make you wonder, how will the next supercontinent form, and when? So far, scientists came up with some possible configurations, each with its own name: Novo Pangea, Pangea Ultima, or Amasia. All these predictions still vary, as we're not sure how and why continents really move over time. One clue may be actually looking at how Pangea separated in the first place. Regardless, it will take anywhere from 15 to 100 million years to see the next future continent, depending on each scenario. Novo Pangea looks at the possibility in which present-day movements continue. In this scenario, the Atlantic Ocean will continue to expand, all the while making the Pacific smaller. The 2 American continents would first combine northward. Africa, Europe, and Asia will have already combined too, by the time they all meet together in one single huge piece of land. Another possible scenario is called Pangea Ultima. In this case, the Atlantic will slow down in its expansion and actually become a landlocked body of water. North America, Africa, Asia, and Europe would become somewhat parallel pieces of land, completely sewn together. Underneath them, South America, Antarctica, and Australia would complete the circle surrounding the North Atlantic. All the while, this piece of land would be surrounded by a large Pacific Ocean. Amasia looks at a scenario that's a bit difficult to understand and study at this point. Since several tectonic plates look like they are moving north, it might be possible that all continents, apart from Antarctica, will slide completely toward the North Pole. The climate would be a lot different and way colder. Both the Pacific and the Atlantic, in this scenario, would remain open bodies of water. Scientists believe this to be a real possibility because of some anomalies left by Pangea deep in the Earth's interior in the part called the mantle. Looking even further into our planet's future, it's estimated that in about 1 billion years, the luminosity of the sun will be somewhere around 10% higher. As such, the atmosphere on Earth will closely resemble that of a moist greenhouse. Because of the added heat, all the bodies of water on our planet will start to rapidly evaporate. Moving further to 4 billion years from now, the temperature on our planet will soon transform it into a Venus look-alike. It might get so hot that the Earth's surface will begin to melt away.
No one will hear your cry in space, or something like that. We've all heard this famous chilling phrase, and it's actually true. Space, for the most part, consists of a giant nothingness. There's a lot of, space in space. But this doesn't mean there are no sounds in space. In fact, there are plenty of them, and some of them can even make you shiver. Let's take a look at the scariest space sounds. First of all, how are cosmic sounds even recorded? Sound is just the vibration of molecules. When you scream, you make the molecules push each other furiously until they reach the ear of the person you're yelling at. Then these vibrations get transmitted to the brain, and we recognize them as something that you might need to apologize for. In other words, to hear something, we need molecules. And that's where things get complicated. There aren't any of them in space. The entire universe almost completely consists of a vacuum. No, not a Hoover. Absolute nothingness. However, the wizards from NASA still record space sound somehow. So how do they do it? The thing is, there are some types of waves that don't care about molecules. We regular folk can't perceive them without some special devices. These waves include, for example, radio waves. We'll need a radio or something like that to recognize them. And that's exactly what NASA's satellites do. They catch random radio waves. Thanks to their heroism, we can find out how different cosmic bodies sound. These satellites record a variety of waves, fluctuations of plasmas, magnetic fields, and other, stuff. And then scientists from NASA transform all this into normal soundtracks. And some of them sound quite frightening, to put it mildly. Let's take our magnetic field, for example. It surrounds our planet like an invisible shield, protecting us from all sorts of nasties, like radiation and solar winds. At the same time, we can neither see it, feel it, nor hear. Oops. Well, the last one is outdated. Scientists from the Technical University of Denmark took magnetic waves recorded by the ESA swarm satellite. They converted them into an audio track and got a pretty creepy result. Now, to be honest, it sounds more like an eerie entity stalking you in the middle of the night. And if you remember the maps of Earth's magnetic field, it starts to feel like a spider crawling nearby. Ew. And this isn't the first strange sound that we caught on Earth. Recently, we caught another weird radio emission from space. Scientists found out that the repeating signal came from somewhere very far away, like billions of light years away from us. Such fast radio bursts usually lasted no longer than a few milliseconds, but this one was unique. It lasted about 3 seconds, basically thousands of times longer than usual. And at the same time, the signal was very precise, so much so that scientists even compared it to a heartbeat. Scientists believe that this signal is caused by pulsars, or neutron stars. One time, Nikola Tesla caught something similar, but unfortunately, at that time, we didn't know about such things as pulsars, so Tesla was sure that he had caught a message from some extraterrestrial life. It's a pity that the truth turned out to be much more boring. But let's move on from the Earth to the Moon. In 1969, the astronauts of the Apollo 10 mission, the spacecraft that made the final test flight to the Moon, flew past its surface. And then they caught some strange signals coming from the dark side of the Moon, the side that we never see because the Moon is tidally locked to us. The sound was so weird that the astronauts weren't even sure whether to report it to NASA. They were afraid they wouldn't be taken seriously, and maybe even not allowed to participate in the next space missions. Here's what it sounded like. But according to NASA, it's not some creepy extraterrestrial music at all. These may just be some radio waves that affected each other because of their proximity, although the astronauts who heard it for the first time probably felt a little creeped out. Let's move to the other planets. Now, 40 years ago, scientists actively explored the surface of Venus. They sent as many as 10 probes there, which were supposed to capture audio and video shooting from the surface. Now we know what Venus, which could easily destroy us at any attempt to even get close to it, sounds like. Horrifying. And you wouldn't expect anything else from the most dangerous planet in the solar system. Unfortunately, Venus is even more toxic than the average Twitter user. So these probes didn't last too long. They heroically arrived on a planet and soon broke down. Next one is Jupiter. This space giant, which is 11 times larger than the Earth, never fails to scare us. One of NASA's probes, Juno, flies around Jupiter every few weeks. The probe is moving at a tremendous speed, 130,000 miles per hour. One day, Juno caught one of the strongest invisible signals it had ever encountered. This was the point at which the mad solar wind came into conflict with the magnetic field of Jupiter. It kind of sounded like a cosmic boom. The original sound lasted 2 hours, but it was compressed to a few seconds. It actually sounds more like a collision of a sea wave and a rock. But here, in terms of horror, Jupiter surprisingly loses to one of its small moons, Ganymede. In 2021, the Galileo space probe flew past Ganymede, and during its flight, it received a rather strange recording. These sounds are satellite radiation, and it's unclear whether it sounds like a cozy sunny day in the jungle or like thousands of bats waiting for you in the night. Next one is Saturn. This signal was caught by the Cassini-Huygens Automatic Interplanetary Station, which was launched into space in 1997. When flying past Saturn, Cassini recorded a pretty scary sound. This terrifying cry of thousands of souls is actually just some radio waves. They aren't too different from what the auroras emit on Earth. A little later, Cassini received another recording, the sounds made by lightning and thunderstorms on Saturn. They sound pretty interesting too. More like popping corn or a Geiger counter, right? But that's just because these lightning strikes have a crazy frequency. Moving on from the solar system to outer space. The famous Voyager 1 was launched back in 1977 and continues to send us data even 40 years after its launch. In 2012, it left the solar system and entered interstellar space in months. But fortunately, scientists felt sorry for us and reduced it to 12 seconds. It isn't really eerie, but is still kind of unsettling. And although it feels like nothing can beat Saturn's horrors, let's end this tournament with one of the scariest objects in the universe, a black hole. This sound was recorded by the Chandra Space Telescope. While studying a cluster of galaxies in the constellation Perseus, they discovered something strange. Some undulating movements appear from the center of the cluster. They spread out in all directions, like circles on the water. Scientists have suggested that this was caused by a supermassive black hole. The thing is, black holes don't always devour space objects entirely. Sometimes they kind of spit them out. This causes vibrations of gases, which we can convert into soundtracks. What's interesting is that the oscillation of each such wave actually lasts about 10 million years. You're just listening to a very accelerated recording. Scientists have reduced the delay between oscillations by about 144 quadrillion times. So let's check it out. This is probably the eeriest sound from the whole list. Nothing too loud or wild, but there's something dark and disturbing about it. Now, those were the scariest space sounds captured by NASA. To be fair, most of them sounded creepy simply because they're radio waves, but it's still fun to get spooked sometimes.
Have you ever wondered how the world will go down in flames? Will it be due to zombies, extraterrestrial civilizations, or AI taking over? Nah, turns out it might actually be mosquitoes and scientists causing the chaos. It's funny how things created by nature aren't as threatening as the stuff that doesn't exist naturally. And you know what's on that list? Editing the DNA genome. Experiments with the genetic structure of living organisms can produce completely new species, and no one knows how nature will react to them. Let's look at an example of gene drive. So it all started with malaria mosquitoes. To somehow stop the growth of their population and prevent the spread of malaria, scientists created a gene that magically made mosquitoes only have male offspring. Several insects with this gene transmitted it to others during the mating season, and thus spread infertility. Scientists were able to stop malaria and destroy almost the entire mosquito population. But imagine if something went wrong in the mosquito genome and their population began to increase exponentially. Malaria could spread across all continents and create huge problems for all of us. Now, let's move from the little mosquito problem to a planetary disaster that can be caused by the desire for knowledge which is deeply embedded in our nature. British cosmologist Martin Rees once said that we lived in the 1st century when human beings could determine the planet's future. It seems that it's so easy not to destroy yourself, but our nature is quite complicated. In pursuit of solving the mysteries of the universe, we have built a giant machine that, according to some people, may destroy our planet. And this device is the Large Hadron Collider. The main task of this giant machine is to accelerate particles and make them collide with one another. Scientists expect that the collider will help better understand the structure of our universe. In simple words, this is a miniature simulator of the universe. Using it may also shed light on the mystery of dark matter. During operation, the machine compresses atoms and makes them crash into one another at great speed. Perhaps this is how our universe appeared. Some people fear that a small black hole may form because of this collision. A tiny particle with a huge weight will pull all objects inside itself. Its mass will grow, but its size won't change much. As a result, it will compress the entire Earth and turn it into a ball measuring a little more than 300 feet across. At the same time, our planet will still have the same weight. A powerful gravitational pull on such a small area of matter can form a black hole that might later swallow up our entire solar system. There are also theories that the Hadron Collider could open a portal to a parallel universe with creepy monsters that would enter our world. But of course, such theories have little to do with science. Scientists have already launched the collider several times, and as you can see, nothing terrible has happened. But there is a small nuance. With each launch, scientists increase the speed of particles. Who knows what will happen when they accelerate them too much? According to Martin Rees, the probability that Earth will become a black hole is very, very small. Particles with a much larger energy charge fly in space faster than in the Hadron Collider, and nothing catastrophic happens. Okay, now let's go back to our genomic games to see what else can happen if we continue experimenting with nature. The main problem might be an imbalance in ecosystems. In the 19th century, sailors accidentally brought mice to Gough Island in the South Atlantic Ocean. Rodents had no dangerous enemies there, so their population began to grow. Mice began to displace dozens of birds from their home. The rodents attacked the chicks and reduced the population of entire species. Trying to save the birds, scientists decided to get rid of the mice, but these little creatures still managed to survive. As a result, the balance of the whole ecosystem was disrupted. Using gene drive to get rid of one species can lead to uncontrolled population growth of another. Imagine that malaria mosquitoes controlled the population of some flies. And what would happen if these flies lost their main natural enemy? The population of these flies would start destroying other species, and it would begin a chain of destructive events. All this suggests that playing with things that don't exist in nature is very dangerous. We worry a lot about how artificial intelligence can take over the world and eliminate us. Still, at the same time, we don't pay attention to our actions. Genome editing can lead to positive consequences, such as the appearance of healthier people, and destructive ones, like the creation of artificial bacteria that can cause serious health problems. In general, destroying other species is a trait inherent in humans. Because of our actions, many animals have disappeared from the face of the earth. Moreover, we even destroy each other. Such aggressive behavior is our nature. And artificial intelligence doesn't have anthropomorphic properties. Its logic may be completely different from ours, and instead of destroying people, it might strive to save them. And we have something to save us from. Remember the giant asteroid that erased more than half of the living creatures on Earth? The fall of the space rock caused a massive blast wave, a tsunami, earthquakes, and dust clouds that covered the sun. Dinosaurs and other animals couldn't survive in such conditions. But what if something similar happens these days? Fortunately, we're better prepared than dinosaurs. Firstly, we have the technology to track giant meteorites and calculate their trajectory. And artificial intelligence can also help us with this. Secondly, we can destroy an asteroid before it reaches us. Several powerful rockets will quickly deal with any space rock and turn it into cosmic dust. Moreover, we will know in advance about its approach. But suppose that a huge stone the size of dozens of Everests will fly towards us. In that case, humanity should hurry with Mars colonization. But don't worry. Observing the sky shows that large asteroids capable of causing severe damage to our planet are moving in a different direction. The most giant known asteroid that could collide with Earth might do so in 2088. The probability that it will fall on our planet is 1 in 50,000, so you shouldn't have to worry about threats from outer space. What lies in the bowels of our planet is much more dangerous. Millions of tons of magma and hot gases can burst to the surface through destructive volcanic eruptions. More than 70,000 years ago, a large-scale eruption threw a tremendous amount of ash into the air, which then floated in the atmosphere in the form of a giant gray cloud for a long time. As a result, Earth's surface cooled down by several degrees, which led to one of the most massive extinctions in the history of our planet. Some eruptions happen not only inside volcanoes. There's such a thing as flood basalts. A colossal magma bubble accumulates under a vast area and begins to seep through faults in different parts. Magma slowly goes out there for many years and destroys all living things around. And the worst thing about this situation is that we can't do anything about it. Humanity has learned to track meteorites in space, but we're still not good at predicting a volcano's behavior. Even if we find out that some giant rock will wake up in the next 6 months, there's nothing we can do about that. We won't be able to prevent an eruption. All we can do is evacuate people from dangerous territory. We have no protection against earthquakes, and even more so, we can't stop the emission of ash into the atmosphere. It's possible that artificial intelligence will help us with this in the future, but right now, we're powerless. As you can see, there are several options for the end of the world for humanity, and they're all slightly different from those imposed by pop culture and the media. In the end, is it right to look for threats from space or artificial intelligence?
Uh-oh, hurricane alert! Everyone's hiding! The speed of the wind outside is more than 75 miles per hour. Seems like a lot, but this storm is moving at 400 miles per hour. Wait, do such speeds exist? Yep, but to see a storm that fast, you'll have to travel to Jupiter. So let the journey begin. The planet is huge. Almost 1,300 Earths could fit into this gas giant. It's also incredibly hot, with the temperatures reaching about 43,000 degrees Fahrenheit at the planet's core. Unfortunately, you can't land on Jupiter's surface because, well, being a gas giant, it doesn't have any solid surface. But you can go deeper into Jupiter's atmosphere. Look at these thick brown, yellow, red, and white clouds passing by. They're what make the planet look colorful and kind of striped. If you continue descending toward the center of the planet, you'll see its atmosphere, mostly made up of hydrogen and helium gas, becoming liquid. It happens because of immense atmospheric pressure. The planet's core itself is a mysterious object. Scientists still haven't figured out whether it's a molten ball of thick liquid or a solid rock 14 to 18 times the mass of Earth. Anyway, exploring Jupiter isn't the main goal of your trip. No, you've arrived here to see the Great Red Spot. It's an enormous storm raging in the southern hemisphere of the gas giant. Its top parts are towering more than 5 miles above the tops of the surrounding clouds. The storm is 1.3 times wider than our planet. In 2017, NASA's Juno space probe managed to collect lots of data about the red spot. And it turned out that this monster of a storm goes more than 200 miles down into the planet's atmosphere. That's 30 to 100 times deeper than any ocean on Earth. But these measurements are most likely imprecise, and the storm's true roots can be reaching even deeper. The Great Red Spot is colder than the rest of the atmosphere. And keep in mind that Jupiter's temperatures are minus 234 degrees Fahrenheit in the upper cloud layers. On the other hand, the closer to the core, the hotter it gets. Mysteriously, the highest temperatures ever recorded on the gas giant occurred in the atmosphere right above the Great Red Spot. There, the heat reached 2,400 degrees. This temperature is higher than that of lava on our planet. Astronomers believe that the turbulence caused by the storm might produce gravitational and sound waves that can be responsible for the superheating, but the storm itself is warmer at the bottom than at the top. People have been watching the moving vortex on Jupiter for more than 150 years. Some time ago, astronomers predicted that it would gradually slow down and become smaller or disappear entirely, but that turned out not to be the case. After having analyzed all the data received with the help of the Hubble Space Telescope, researchers were baffled to discover that the winds at the outer boundaries of the storm had actually picked up speed. The change in the wind speed is no more than 1.5 miles per hour during one Earth year. It's a tiny change, but however small the difference is, it still means a lot. The wind speed at the edges of the storm can reach a mind-boggling 400 miles per hour. That's faster than Earth's tornadoes. At the same time, if you found yourself at the center of the Great Red Spot, you wouldn't be too impressed. The winds there move way more slowly. Scientists faced lots of challenges when they were trying to understand the mystery that was the Great Red Spot. It's unclear what fuels the storm. Can it be the nature of the storm's home planet? Since it's a gas giant, Jupiter doesn't have any solid ground, so there's no friction, which might be the only thing that could make the storm weaken. The hot gases in the planet's atmosphere are always moving, rising, falling, swirling, just like on our home planet, where cooler and warmer air mix and merge into one another, forming giant circling storms. Astronomers think that once, several enormous storms could have come together and created the Great Red Spot. And now, it keeps going by constantly drawing cool gases from below and hot gases from above. Plus, the storm might be absorbing other smaller vortices. This makes the Great Red Spot even more powerful. Unfortunately, thick clouds on Jupiter don't allow astronomers to see what's going on in the planet's lower atmosphere. Scientists have been speculating on what may hide beneath the Great Red Spot for decades. Is it a massive volcano? Unlikely. Jupiter is mostly made up of gases, and it doesn't have a crust that could crack, letting lava escape from the planet's interior. There are also a few theories explaining why the storm has its trademark color. It varies from whitish and pale salmon to bright orange and brick red. Some scientists believe the answer lies deep below the Great Red Spot, closer to the planet's surface. A colorless layer of gas might be reacting to the UV radiation coming from the sun. This is probably what gives the storm its red color. But so far, it's just a theory. Hey, your guess is as good as mine, huh? Jupiter isn't the only planet that can boast having a giant storm. Another one, as wide as our home planet, rages on Saturn. It's called the Great White Spot. How clever! The storm has a tail of white clouds encircling the entire planet. It occurs every 30 years or so. The storm indeed starts as a spot, but then it starts stretching and stretching. Astronomers have figured out that the Great White Spot is actually a huge system of thunderstorms. At the top of the storm, lightning can flash more than 10 times per second. But the main mystery about the Great White Spot is where it gets its energy from. Some scientists think it may be powered by the sun. Others argue that the storm's cloud pattern only makes sense if there's an internal source of heat that can power the winds. Anyway, severe storms on different planets of the solar system aren't the only space mystery that makes astronomers scratch their heads. Let's move to Pluto, the largest known dwarf planet in the solar system, and explore its atmosphere. It rises really high above the surface of the planet and has more than 20 layers, all of them freezing cold and extremely condensed. By the way, our moon also has some sort of an atmosphere. Called an exosphere, it consists of helium, neon, and argon. It's 10 trillion times less dense than Earth's atmosphere. While traveling through space, watch out for black holes. Woo! A black hole is a place where gravity is so strong that even light can't get out. But black holes can sometimes behave like a massive galactic volcano. From time to time, they flare up. Sounds like me. But instead of spewing lava, they produce enormous amounts of energy, and this phenomenon leaves gaping holes in the surrounding material and gas. A short while ago, scientists discovered one of the largest craters in the universe. radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light-years away from Earth. The crater this event left behind could fit 15 Milky Way galaxies. Yeah, I can't get my head around that either. During your space voyage, think twice before landing on unknown planets. Otherwise, you may end up in a place like K2 141b. That's a planet outside of our solar system. At first glance, it's not that different from Earth. It has liquid oceans that evaporate, form clouds, condense, and get back to the surface as rain. But instead of water, it rains rocks. The surface of this exoplanet is covered with lava seas dozens of miles deep. The temperatures on the K2 141b reach 5,000 degrees during the day. That's toasty enough for the magma in the oceans to vaporize into the atmosphere. Then, supersonic winds, which can move at the speed of 1 mile per second, carry this rock vapor into the planet's night side. The vaporized magma cools down, becomes liquid again, and falls as a rocky rain. Not a vacation spot. Too hot. I'll pass. Venus most likely used to be covered with oceans, from 30 to 1,000 feet deep. Also, some water was locked in the soil of the planet. On top of that, Venus had stable temperatures of 68 to 122 degrees Fahrenheit, which, you have to admit, was quite pleasant and not that different from the temperatures on Earth nowadays. So, what I'm getting at is that for 3 billion years, right until something irrevocable happened 700 million years ago, Venus could have been habitable. But now it's not. The Moon is the second brightest object in our sky. At the same time, among other astronomical bodies, it's one of the dimmest and least reflective. Our natural satellite only seems bright because it's so close to Earth. For comparison, our planet looks much brighter when you look at it from space. It's because clouds, ice, and snow reflect way more light than most types of rock. Triton, Neptune's moon, has all its surface covered with several layers of ice. If this satellite replaced our current moon, the night sky would get 7 times brighter. Neutron stars are some of the smallest yet most massive objects in space. They're usually about 12 miles in diameter, but are several times heavier than the Sun. Oh, and they also spin about 600 times per second, far faster than your average figure skater. Saturn is the least dense planet in the solar system. It has 1/8 the average Earth's density. And still, because of its large volume, the planet is 95 times more massive than Earth. A transient lunar phenomenon is one of the most enigmatic things happening on the Moon. It's a short-lived light, color, or some other change on the satellite surface. Most commonly, it's random flashes of light. Astronomers have been observing this phenomenon since the 1950s. They've noticed that the flashes occur randomly. Sometimes they can happen several times a week. After that, they disappear for several months. Some of them don't last longer than a couple of minutes, but there have been those that continued for hours. The year was 1969, one day before Apollo 11 landed on the Moon. One of the mission participants noticed that one part of the lunar surface was more illuminated than the surrounding landscape. It looked as if that area had a kind of fluorescence to it. Unfortunately, it's still unclear if this phenomenon was connected with the mysterious lunar flashes. Trash isn't just a problem in Earth's oceans, cities, and forests. There is a thing called space junk, which is any human-made object that's been left in space and now serves no purpose. There's also natural debris from meteoroids and other cosmic objects. There are currently over 500,000 pieces of space debris orbiting the Earth at speeds high enough to cause significant damage if they were to collide with a spacecraft or satellite. NASA does its best to track every single object to ensure that missions outside Earth can reach their destination safely. Our Sun is insanely massive. Want some proof? 99.86% of all the mass in the solar system is the mass of the Sun. In particular, the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. The Sun's temperature is hotter than the surface of a star. The surface temperature reaches 10,000 degrees Fahrenheit, but the upper atmosphere heats up to millions of degrees. If someone could dig a tunnel straight into the center of the planet and out the opposite side, and you were adventurous enough to jump into it, it would take you 42 minutes to fall to the other side. You'd speed up as you fell, reaching maximum speed by the time you reached Earth's core. After the halfway point, you would then fall upwards, getting slower and slower. By the time you reached the opposite surface, your speed would be back to zero. Unless you managed to climb out of the hole, you'd immediately start falling again, back down or up to the other side of the planet. This trip would go on forever, all thanks to the weird effects of gravity. Hey, might be a fun way to spend an afternoon. There might be more metals, for example, titanium or iron, in lunar craters than astronomers used to think. The main problem with this finding? It contradicts the main theory about how the moon was formed. That theory says that Earth's natural satellite was spun off from our planet after a collision with a massive space object. But then, why does Earth's metal-poor crust have much less iron oxide than the moon's? It might mean the moon was formed from the material lying much deeper inside our planet. Or these metals could have appeared when the molten lunar surface was slowly cooling down. Or maybe, as they've been saying for centuries, it's made of green cheese. Earth could have been purple before it turned blue and green. One scientist has a theory that a substance existed in ancient microbes before chlorophyll. That thing that makes plants green evolved on Earth. This substance reflected sunlight in red and violet colors, which combined to make purple. If true, the young Earth may have been teeming with strange purple-colored critters before all the green stuff appeared. The highest mountain in the solar system is Olympus Mons on Mars. It's 3 times as high as Mount Everest, the Earth's highest mountain above sea level. If you were standing on top of Olympus Mons, you wouldn't understand you were standing on a mountain. Its slopes would be hidden by the planet's curvature. Astronomers have found a massive reservoir of water in space, the largest ever detected. Too bad it's also the farthest, 12 billion light-years away from us. The water vapor cloud holds 140 trillion times as much water as all the Earth's oceans combined. What are we supposed to do with that information? Venus spins at its own unhurried pace. A full rotation takes 243 Earth days, and it takes the planet a bit less than 225 Earth days to go all the way around the Sun. It means a day on Venus is longer than a year. There's very little seismic activity going on inside the Moon. Yet many moonquakes, caused by our planet's gravitational pull, sometimes happen several miles below the surface. After that, tiny cracks and fissures appear in the satellite surface, and gases escape through them. Hey, they sometimes escape from me, too. Now, Mars is the last of the inner planets, which are also called terrestrial since they're made up of rocks and metals. The red planet has a core made mostly of iron, nickel, and sulfur. It's between 900 and 1200 miles across. The core doesn't move. That's why Mars lacks a planet-wide magnetic field. The weak magnetic field it has is just 1/100th% of the Earth's. When the planets in the solar system were just starting to form, Earth didn't have a moon for the longest time. It took 100 million years for our natural satellite to appear. There are several theories as to how the moon came into existence, but the prevailing one is the fission theory. Somebody went fishing and caught the moon? Actually, no. The fission theory proposes that the moon was formed when an object collided with Earth, sending particles flying about. Gravity pulled the particles together, and the moon was created. It eventually settled down on the Earth's ecliptic plane, which is the path that the moon orbits. So, looks like the green cheese is off the table now. The largest single living thing on Earth turns out to be a mushroom in Oregon. This enormous honey mushroom lives in Malheur National Forest and covers an area of 3.7 square miles. It could be as much as 8,500 years old. You could be forgiven for missing it, though, since most of it's hidden underground. When the roots of individual honey mushrooms meet, they can fuse together to become a single fungus, which explains how this one got so big. If you could gather all that mushrooming stuff into one big ball, it could weigh as much as 35,000 tons. That's about as heavy as 200 gray whales. Hey, that's a whale of a mushroom. Hehe. The largest asteroid in the solar system is called Vesta, and it's so big that it's sometimes even called a dwarf planet. A trip to the nearest star, apart from the Sun, would take you 5 million years on a commercial airplane. That's what I call a long-haul flight. Space isn't supposed to be black. There are stars everywhere. Shouldn't they light up everything around? Well, you don't see stars wherever you look because some of them haven't existed long enough for their light to reach Earth. A day on Uranus lasts 17 hours, 14 minutes, and 24 seconds. But get this, the planet has a tilt of around 98 degrees, and that makes a season on the gas giant last 21 Earth years. Now, some scientists believe that our planet used to have an additional satellite. According to their research, a small celestial body about 750 miles wide orbited Earth like a second moon. It most likely crashed into our main satellite later on. Such a collision could explain why the two sides of the moon look so different from each other, one being heavily cratered and rough. Or it could be the green cheese. What would happen if our planet turned into two separate ones, one consisting entirely of land and the other one of water? Could we survive on any of them, and how? Well, you're lucky, because I'm going to answer this question right now. So let's imagine that our Earth has turned into two separate planets sharing one orbit. Let's call these hypothetical planets rock and water. I know, very original. Anyway, let's start with the rock because this one is much easier to imagine. All we should do is ask, what would happen if all the oceans on the Earth suddenly dried up? Now, we know that water is life. It covers 70% of the surface of our planet. There's so much water that even if all the oceans and seas disappeared, some of it would still be left in underground rivers, streams, and so on. But unfortunately, it would not be enough for us to survive. All sea creatures disappear. After some time, all other animals, plants, and of course, people share their fate. Completely dried forests burst into flames sooner or later and burn until there is nothing left but ashes. But hey, it's not that bad. Well, it is bad, but life can still exist in some form. There are some bacteria that make cockroaches jealous. They're able to survive absolutely any conditions. For example, extremophiles have already evolved to live without water. These little guys can survive in an incredibly hot or acidic environment without water or even sunlight. Without them, the rock becomes an empty, lifeless planet. Although, who knows? Maybe someday extremophiles will be able to evolve into some wildly cool forms that can survive literally anywhere. But for now, the rock is just a floating rock, basically. Oh wait, did you imagine a hot desert or some sort of red-hot steppes? Surprise, surprise! This planet is actually extremely cold. You see, without water, there would be no atmosphere. The atmosphere consists of a concentration of various gases, including hydrogen and oxygen. Some H and O, you know where this is going, right? Yep, no water, no atmosphere. And since it is the atmosphere that accumulates all the heat we need, the planet would be very cold without it. The contrast between cold and less cold places also becomes very sharp. You see, water is basically a climate stabilizer. The oceans absorb almost all of the heat of our sun. They distribute it evenly over the Earth to make sure it doesn't get too cold or too hot. So without it, the rock gradually turns into a cold desert. The average temperature on this planet is around minus 100 degrees Fahrenheit. At both poles, the temperature is extremely low, about minus 300 degrees. And even in the warmest places, it doesn't exceed 20 degrees. These warm places are now the former oceans because their dried-up depths are located much closer to the hot core of the planet. Wait, I hope you don't imagine this planet as covered in snow either. We don't have any water at all, remember? It's just a very cold rock. At this point, we're just a bigger and browner version of the moon. The moon is basically a waterless piece of Earth, after all. But hey, what happens to volcanoes? They're basically our last hope to stay warm, aren't they? Unfortunately, volcanic activity is decreasing due to a lack of water. You see, volcanoes and their eruptions happen because of the collisions of two tectonic plates, the oceanic and continental ones. The weight of the water presses on the oceanic plates. They go under the continental plates and form volcanoes. So if there's no water weight, then there's no volcanoes and volcanic activity drops significantly. The rock now is just a planet full of many incredible high mountains. And every time the tectonic plates collide, they form more and more of these mountains and trenches, including some very big ones, like the famous Mariana Trench. I would say, be careful not to fall, but hey, there's no one to fall there. Also, there's no weather anymore. No water means no more snow, ice, or rain, or even clouds. The wind would probably be quite strong, though. Well, that's the fate of the planet rock. Not very bright, so let's just go see how the water planet is doing. Many, many billions of years ago, I wasn't around then, our Earth actually was a planet entirely covered with water. Then, about 1 billion years ago, the sea level dropped, the land appeared. This has changed the atmosphere of our planet forever, and that's how life was born here. But what happens if it returns to its original state? Well, to answer that question, we should first learn more about the ocean planets. So, what does one of these look like? Oh, sorry, I almost forgot. We have no idea. We haven't found any planets of this type because they're incredibly rare. I mean, there is one planet that is low-key and could be called an ocean planet. Yeah, I'm not even going to try and pronounce that. Still, even this one doesn't look the way you probably imagine. The water on it is in a very weird, unique state. Scientists have called this hot ice or superliquid water, and we've never seen anything like this before. In general, though, the actual ocean planets are very hard to find due to many physical reasons. These planets require very specific temperatures, pressures, and so on. But alright, just hypothetically, what would such a planet look like? Well, first of all, of course, it cannot be made entirely of water. I hope you didn't actually think that there could be just some gigantic water blob spinning around a star. It should still be a planet with a core and some kind of foundation. So let's just imagine that all the water on the former Earth has mixed into one giant salty ocean. Wow, that would be a dream come true for the sea creatures, but not for the rest of us. The only animals that could survive in this situation, except fish, are probably the birds that can swim and feed on fish. Now, I think even if the sea level rose significantly, at least a couple of islets could still stay above the water. Such islands would be the former peaks of huge mountains like Mount Everest. So if these birds build their nests there, they can even survive for some time. But what about you and me? Well, we still have a chance. If we had enough time to prepare for the huge flood, we could stay safe either in giant submarines or on giant ships. We can grow food on board and fish from the ocean. But without the Everest Islands, we are unlikely to last long. If something breaks and we have nowhere to dock, we won't be able to fix it. Unfortunately, we no longer have drinking water. Now we can get it only from rain or by filtering seawater. But we have to store it someplace, right? And all these water containers would take up a lot of space and be very heavy. But in general, planet water is not as bad as it might seem. It's quite warm. The average temperature here is about 50 degrees Fahrenheit. And the gap between the lowest and highest temperatures is minimal, from minus 20 degrees at the poles to 70 degrees at the equator. Compared to planet rock, this ain't bad at all. Planet water would also be slightly larger than the Earth in radius due to the volume of, yes, water. The density of this planet would be, on the contrary, quite low. The gravity could become a bit weaker, too. Now, as for both planets, if we place them in the Earth's orbit, after some time, they would still move away from each other and follow different trajectories. They would have aligned themselves not to collide with each other. On one of them, the year would last 12 months, and on the other one, 10 or 11. And that's about it. A fun fact. All of this can actually happen in the future. First of all, the Earth's crust is gradually becoming thinner. Hey, I like thin crust. On my pizza. On my planet, not so much. So, one day, water can really flood our entire land. On the other hand, in a couple of billion years, when our sun begins to expand and turn into a red giant, all the oceans on our planet will really dry up. Alright, take a deep breath and shake it out. That's enough of this grim fairy tale. It's a waste of time to worry about such things so far off when, today, I can't find my wallet anywhere. I thought I put it over here.
The weird thing about Fomalhaut b isn't its name, but the fact that it doesn't exist. It was first photographed back in 2008 and was a sensation. Scientists believe it to be a massive exoplanet, but it turned out to have low mass, and it's falling to pieces of dust at the moment. It acts like a massive dust cloud. Gliese 1214b is quite extraordinary with its steamy environment. Wait, but steam is the result of water evaporation, isn't it? In fact, this hot planet is full of water-like substances. It's definitely hotter than our planet, with its 250 to 540 degrees Fahrenheit. It can also be an ocean planet. Still, very little is known about it since it was first discovered only back in 2009. If you ever wondered what it's like to walk on ice and hot coals at the same time, meet Gliese 436b. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. But Gliese seems a nice place with quite mild climate compared to an oven-like Corot 7b. Its stated day temperature is over 4,000 degrees Fahrenheit. Combined with the rocky surface, it presents a kind of underworld landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Corot 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. Corot Exo 3b is neither as hot as the previous one, nor as cold as many other planets. It's a gas giant similar in size to Jupiter, yet 20 times denser. It makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. TRES 2b is a planet where night never ends, and it's not your regular night with stars shining in the beautiful skies. Here, it's pitch dark and scorching hot. TRES 2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. It may mistakenly seem that Saturn does have an Earthen-friendly environment. Some layers of this giant gas sphere actually have quite nice temperature conditions. If you dive into Saturn, you'll get to a layer with liquid molecules with 32 degrees Fahrenheit, which seems like Earth. Anyway, it's only one minor layer, and the rest of the planet is freezing cold. So you'll never be able to land on Saturn and be the same human being like you are on Earth. But you can become a sort of snowball there, or an ice crystal. As for Jupiter, you might have already guessed that there's no solid land. This planet is made of hydrogen and helium, so it's another gas sphere you can't walk on. It's a bit different from Saturn though. You wouldn't dive in Jupiter, you'd rather float on it. This planet is like a giant cloud, and if you ever landed on it, it would be like walking through a super thick fog. The temperatures fluctuate a lot here. It's freezing on the surface. Unlike Saturn, the deeper you dive, the more scorching this gas sphere gets. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot where anything that could burn will. It's also responsible for a very short orbit of the planet around its star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. WASP 76b is another weirdly dangerous planet where it rains. No, not wasps. It's so hot out there, over 4,300 degrees Fahrenheit, that it vaporizes iron. So, it rains iron. It's another gas giant, just like Jupiter. Its extreme proximity to the sun divides the planet in two. One half has a never-ending day, while the other has eternal night. Meet WASP 12b. one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planet consisting mostly of gas, result in the star slowly devouring its protege. WASP 12b has already taken the form of an egg, stretched towards its merciless sun and unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. No list of the weirdest planets could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury, despite being somewhat farther from the Sun. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water, but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through those clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. One more freezing cold planet is the one I dare not pronounce. Although the host star is not too far away, it's a small and rather cool red dwarf whose light and heat barely even reach the planet. The temperatures out there fall as low as -370 degrees Fahrenheit, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice. Still, if it has a rocky core, it might generate some heat, so there is a chance that deep below the frozen surface, we could build a nice thermal spa hotel for space travelers. The next planet that sounds like a tongue twister is the only exoplanet in the orbit of its star, and at first glance, it looks quite pretty. Blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst thing is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. For comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Here's another name we'll just leave on the screen, thank you. This magnetic rogue planet, let's call it SIMP, has probably the best auroras in the universe, putting our northern lights to shame. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees Fahrenheit, perpetually blown over with winds reaching 600 miles per hour. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when these cool down, they fall on the surface in the infernal rain of molten iron. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather, the first, because it's closest to the star, is different in a most horrible way. 55 Cancri E is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star with one side. And between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. The system whose name I wouldn't even try to pronounce has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular one. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions, while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely.
Hey there! Imagine a place on Earth that's just like Venus. It's Chile's Atacama Desert. I assume you wouldn't want to spend your holidays there. Similar to other deserts, this one isn't exactly the friendliest place. It's a long stretch of land close to the Andes Mountains. This makes it one of the driest spots on the planet. In fact, it's so dry that only a few places in Antarctica have stayed without rain for longer. This tough environment has some benefits to offer. Because it's located high up and doesn't have many clouds or a lot of light pollution, it's become the perfect home for advanced telescopes. These telescopes help us explore the cosmos. A new study from June 2023 revealed that this desert is even weirder and more out of this world than we had thought. It makes sense that a desert as dry as this one gets a lot of sun. On average, it has about 308 watts of sunlight per 10 square feet. That's almost twice as much as places like Europe or the eastern United States get. Raul Cordero is a scientist. He and his team checked out the sunlight in the spot housing the biggest telescope project ever, the Atacama Large Millimeter Array. And this is the sunniest place on Earth. This is what you'd experience if you were about 79% of the way from the sun to Earth. Of course, if you were actually on Venus, you would have way bigger things to worry about than just a lot of sunlight. Now let's figure out why this place is almost as sunny as Venus. It's because of clouds. Usually, clouds block sunlight and keep us cool, but sometimes they can act like a magnifying glass in special situations, concentrating the sun's rays. This is called forward scattering. This happens when certain types of clouds show up during the South American monsoon in the middle of the summer. During the summer in the southern hemisphere, we're actually a bit closer to the sun, and there's less ozone in that part of the world. This combo might explain why other high places on Earth, like the Himalayas, don't get as much intense sunlight as this desert. Let's talk more about Venus. What would it be like to stand on the surface of this planet? The more you learn about this sweltering world, the less you want to picture yourself there. It's not a friendly place at all, with crazy heat and super heavy air that could crush you. But pretend for a moment that you're on Venus. The air there is thick and heavy, 93 times denser than what we have on Earth. The air presses you down. Think of having a small car resting on your thumbnail. That's how it would feel. Or think about diving really deep into the ocean. You'd feel a lot of pressure pushing on your body. But on Venus, it's like having all the pressure of the atmosphere squishing and almost flattening you. What is the weather like on Venus? Ouch! Heat. Even though Mercury is closer to the sun, Venus wins the prize for the hottest planet's surface. That thick air on Venus is mostly carbon dioxide, which acts like a blanket. When the sun shines on Venus, the heat gets trapped by this blanket of air, and the planet heats a lot. Temperatures on Venus can hit 860 degrees Fahrenheit. Now, how do we explore Venus without getting roasted or squished? Well, going there in person is a no-go. Robots can handle it, yet even robots have struggled on Venus. Only a handful have made it to the surface. And they only managed to survive for a few hours before getting wrecked by the harsh conditions. The good news is we're figuring out ways to study Venus without putting anyone at risk. Future missions will check Venus out from above. Spacecraft up there will be able to see through the atmosphere without any trouble. NASA's got the Veritas mission. Its aim is to make detailed maps of Venus from orbit, giving us a new view of the place. So we've examined the driest desert on our planet, the Atacama Desert. No wonder this area is the place that serves as testing grounds for space missions. But despite how arid this region is, there is life there. This is a realm of flamingos and lagoons. The place has colossal salt flats that extend for 4,633 square miles at a depth of 82 feet. It's a place of erupting geysers, naturally heated springs, towering volcanoes, herds of llamas, and deserts so parched that certain pockets have remained untouched by rain for over half a millennium. All this unfolds 2 to 3 miles above the sea level. What else survives in the Atacama Desert? It's quite hard to fathom that plants could thrive in such inhospitable conditions. Yet, they managed to survive here. Take, for instance, Tillandsia landbecki. These plants defy the odds in the desert by extracting moisture from the fog that rolls in from the nearby coast. This fog water can also serve as a sustainable water source for humans. These plants lack traditional roots. Instead, they use their older, deceased parts to anchor themselves in the sand, forming little dune-like structures. They draw moisture out of the mist through their slender leaves and shoots, which swell upon contact with water. Nocturnal dew also provides water, particularly during the summer when fog is scarce. Together, plant communities existing there are known as lomas vegetation. The presence of this vegetation in the Atacama Desert is limited to a narrow coastal area where fog regularly occurs. Factors such as the distance from the Pacific, prevailing wind direction, and topography restrict the distribution of fog ecosystems. Satellite data analysis reveals that plants grow at altitudes ranging from 2,625 feet to 4,100 feet above sea level and up to 28 miles inland. They are mainly found on sandy plains along fog corridors or on slopes. They're about as tall as 1.5 feet, and they usually form a line. This clever lineup helps them catch all the moisture and yummy nutrients they need. The arrangement of these clusters depends on how much foggy water they can find. These tough desert plants are like water wizards of the plant world. They're so good at surviving in the desert that they give us ideas about getting water from fog. Water is precious in places like Iquique and small villages near the desert. Plus, with all the digging for stuff like copper and lithium, which makes batteries work, they need even more water. Usually, people get drinking water from under the ground, but these little plants have something to teach us. Using this trick, we're making a map showing where these plants like to party most. This map could help us find perfect spots for catching fog with special nets. Here's another idea that will make you feel like you're on the surface of another planet. Pelican Point is in Namibia. You might not expect it, but Pelican Point is actually a great place to surf. Every year, it only gets around 0.30 inches of rain, but that doesn't stop surfers from riding the waves. The weather is kind of unique here. It's hardly ever too hot or too cold. This place has an unusual type of dry climate, thanks to the cold ocean currents near the bay. Skeleton Bay, alternatively named Donkey Bay, is an iconic surfing location. The surf wave crashes onto the sands of Pelican Point, situated about 5 miles northwest of Walvis Bay, a compact harbor town famous for its sand dunes and secure anchorage. Would you surf there?
Ah, Earth. The third rock from the Sun. The blue planet. You get it. Its atmosphere is made up of around 78% nitrogen, 21% oxygen, and 1% argon, water vapor, and carbon dioxide. A nice balance for any living creatures to breathe. The weather here is also perfect for life to exist, unlike places like Saturn, Mercury, or any other celestial object in our solar system. We have the troposphere to thank for that. It's the densest part of the atmosphere on our planet and is 5 to 9 miles wide. It's the layer of the atmosphere that always affects our weather and secures the right conditions for life to exist and to have bodies of water. Earth is just sitting in its orbital path, minding its own business, revolving around the Sun until, BAM! Venus and Mars swoop in and spoil the fun. No one wants to leave poor Earth alone. These two relatively large celestial objects moving toward Earth will have dire consequences for our planet, starting with changes in its orbiting trajectory path. The planet's orbits in the solar system have to maintain the right balance so that nothing goes haywire. Of course, if any large object approaches Earth, it would throw our orbiting path off course. The planets will revolve around each other, which will cause plenty of natural disasters on our lands. This will also affect our rotation timing, potentially slowing it down. Days will not flow but drag by. Animals that rely on daytime will need to readjust their biological clocks. Nocturnal animals will also need to figure out how to cope with the long nights. Humans have adjusted pretty well to the 24 hours a day timing. Time itself is just a human construct to measure things. We'll have a tough time sleeping and adjusting to the stretched day. Marine animals rely on the natural current flow to migrate around the oceans. With Mars and Venus crashing the party, it looks like they will also need to find new paths. Birds migrating to other lands throughout the year will also be confused and not know what to do. In general, the Earth's temperature will rise, and massive heat waves and permanent climate changes will occur. This brings us to our next issue, the heat. The radical temperature rise will turn everything into a barren desert. It'll be summer all year long, especially if Venus is in the picture. Most of the planet will dry up and won't be suitable for growing crops. Venus is hot, really hot. Even though it's not the closest planet to the Sun, it's still the hottest. The temperatures on Venus are close to 900 degrees Fahrenheit, which will melt you like an ice cube. The lands on Venus are generally flat, probably due to the temperatures. It's mainly hot because its atmosphere is thick and traps the hazardous gases inside. If Venus inches its way towards us, it'll invite those gases to our atmosphere and compromise it. Mars, or the red planet as we know it, is very cold. That might stay the same if it starts rotating around us. It's also home to the largest dormant volcano in our solar system, which makes Mount Everest look like a tiny bush compared to a tree. With so much instability, it might just wake up one day and spew out molten lava. Mars has a very thin atmosphere, which makes the planet chilly. Its gravity is quite similar to ours. It's actually very cold and has ice caps in the poles covered with carbon dioxide. The same's true for Mercury. You can only last there as long as you can hold your breath and be in the sweet spot between the sunrise and sunset. The three planets orbiting each other will eventually collide. It's just a matter of time. And the moon, just hanging out like a fly on the wall, will be so insignificant that something will eventually throw it off course and another planet will capture it to its orbit. Or, in the most dire case, it will collide with one of the two intruding planets. Earth will experience extreme tidal waves like nothing before. The two new planets revolving around Earth will cause a major imbalance, making our gravity shift out of control. Each tidal wave will be bigger than the previous one and will cover the dry land. Plenty of little scattered islands in the oceans will be completely submerged. Coastal cities and towns will also be home to fish. Flat countries in general will need boats to get around. Dams and dikes won't be enough to stop the water from coming in. Everyone needs to move towards higher ground to escape the floods. With the climate getting hotter, the polar caps will melt like ice cream on a sweltering summer day and add to the water level rising. Within a few months, the whole Arctic will be nothing but liquid. But wait, there's more! The crust will wear out due to the instability of the Earth's surface and fluctuating gravity. The Earth's crust is mainly made up of oxygen, which means we're basically walking on air. We might experience more earthquakes than before, and dormant volcanoes will wake up from their deep slumber. The skies will be covered in ash, making flights impossible. No one can travel by sea or by air. Importing and exporting will become history. The overall climate will get hotter, just like in Venus. The three planets orbiting each other and their huge mass might even unintentionally welcome other planets and celestial bodies to join the party. So, what if Jupiter decided to turn up? Now, Jupiter is the largest planet in our solar system. To give you an idea, the Earth would be just the size of a grape if Jupiter were the size of a basketball. It also has the largest storm we can perceive. That's known as the red spot, a place twice the size of Earth that has hurricane-like storms that have been going on for hundreds of years. Now, by the time you're done watching this video, you can expect the storm to still be going at it. Since the planet is huge, gravity must be quite strong here. It also has many moons, some of them of our little Earth. There will be no room for any proper space among the planets. Jupiter's moons will be thrown off course and latch onto other planets around. Some of the moons might collide with each other, causing massive debris to be displaced all over the place. The gravity of the planetary party will attract comets to enter the atmosphere, potentially crashing down on us. Oxygen levels will deplete, so the Earth's crust crumbling will continue. It'll rip open the ozone layer, causing heavy strokes of ultraviolet waves to enter our atmosphere. We won't be able to step outside for too long without some protective gear and oxygen tanks. Human civilization will change drastically. We'll all live in sheltered containers that will provide clean air and safe and filtered sun rays. The shelters will be sturdy enough to withstand frequent earthquakes. We will grow only enough crops to sustain ourselves until we leave the Earth. Since it'll only be a matter of time before the planets collide, the next step would be to create large rocket ships to fly us out of the Earth. With Mars, Venus, and Jupiter revolving close to us, it won't be easy to do so. All the space debris will be blocking us from exiting the space zone area. The only safe place outside this region will be many millions of miles away, where only single planets exist. They may or may not have the conditions to host life, but humans will have the technology to land just about anywhere with similar gravity and construct the right shelters. Eventually, Mars, Venus, Earth, and Jupiter will collide with each other and break like eggs, like a big space omelet. Don't forget the moon's crashing and breaking in the mix, but we'll already be far, far away by then, hopefully. So check this out. Astronomers have discovered an exoplanet they're calling Super Saturn. It's got rings over an AU wide. An AU is the astronomical unit, the distance between the Sun to the Earth. That's an incredibly huge ring system, hence its name. Super Saturn is being called Mamajek's object after the astronomer who led the team to whom we owe the discovery. Professor Eric Mamajek of Rochester University in New York found Super Saturn while scouring through data downloaded from wide-angle transit observations. WASP is the acronym for Wide Angle Search for Exoplanets. It's an ingenious project developed in the year 2000 by astronomers at Queen's University in Belfast, Northern Ireland, and St Andrews University in Scotland. Using 4 telescopes, the CCD video cameras on the scopes record the slight dimming of starlight caused by objects passing in front of stars. This is called the transit method of exoplanet detection. So, for example, the planet Venus transits across our view of the Sun every couple hundred years. A black dot, the silhouette of Venus, is visible, crossing in front of the Sun as Venus passes between our line of sight and the Sun. This tiny eclipse causes the amount of sunlight coming to Earth to be reduced by a minuscule amount, also known as teeny tiny. The same is true for all the stars in the Milky Way that have planets going around them. Exoplanetary transits in front of stars must be in direct line of sight with Earth for the starlight to be dimmed. Such transits do not occur very often. That's why thousands of stars must be looked at simultaneously for as long of a duration as possible, between 4 and 8 hours a night. WASP was created to stare continuously at as wide of a range of stars as possible. Maybe one of them would show an exoplanet transit. That translates into a lot of data being produced, about 40 gigabytes per viewing session. Computer scientists at Leicester University in England developed a computer program to store the data and generate photometric graphs of the light intensity of each star. Open University, also in England, joined the WASP project, took this data, and made it available for research by astronomers worldwide. The graphs of the intensity of starlight show that changes in its brightness are called light curves. These graphs have 2 axes. One is in the timeline axis, the other one is the intensity of light. As the object, considered an exoplanet, though it could also be a brown dwarf star, crosses in front of the star, the timeline axis keeps track of how swiftly it is moving. It tells us how close the object is to the star, while the brightness axis keeps track of how much the starlight dims. This way, we can find out how large the object is. Now, obviously, big objects will dim the light more and be easier to detect. At present, Earth-based equipment is not sensitive enough to measure the dimming caused by planets as small as Earth. Neptune-size and larger ones are the limit for WASP. However, the James Webb Space Telescope, which is now in operation, has a much greater sensitivity and will be able to resolve the transits of Earth-sized exoplanets. Now, I know you want me to get to Super Saturn, but there's something else you should be familiar with before we get there. If the exoplanet has an atmosphere, or, in the case of Super Saturn, a ring system, the starlight from the star the planet is transiting will shine through the atmosphere or ring system, and that can be detected too. The light curve will show less dimming in the photometric data, because not all the starlight is being blocked. Some light is still getting through the atmosphere or rings. This is important because it gives astronomers a reading of the atmosphere. The James Webb Space Telescope is fitted with spectroscopes that can determine the gas content of the transiting exoplanet atmospheres: oxygen, methane, carbon, etc. The WASP project has been really catching on. There's a Super WASP project now consisting of WASP North and a WASP South. One looks at the sky above the northern hemisphere, the other looks at the sky above the southern hemisphere. There's also a Next Generation Transit Survey, NGTS, based on the WASP project. It's automated, so astronomers don't have to stay up all night sipping coffee, but they can if they want to. Located at the European Southern Observatory in the Atacama Desert in Chile, the NGTS scans millions of stars and has discovered over 100 exoplanets, down to a size as small as 3 times the size of Earth. NGTS has started a Planet Hunters Club on social media. Citizen scientists can search the online database of light curves and perhaps discover your very own exoplanet. What had been a strictly British effort started by 1 or 2 astronomers is now a worldwide phenomenon. With the ability to read the spectroscopic signatures of atmospheric gases during exoplanet transits, a new idea emerged: technosignatures. That is, specifically identifying gases in exoplanet atmospheres that are produced by civilizations. The James Webb Space Telescope can do this. Gases from pollution, such as chlorofluorocarbons (CFCs), can be seen spectroscopically if present. Tritium from fusion reactions, if they have them, can also be detected, along with heat patterns from cities on the planet's surfaces. Technosignatures is a recent concept that originated after the WASP project started. Who knows what it will turn up? Now, let's get back to Super Saturn. The star that Super Saturn orbits is J1407, a small, dim, sun-like pre-main sequence star of the 13th magnitude. Huh? Well, the human eye can only see stars to about the 6th magnitude, and each magnitude is 2.5 times dimmer than the previous one. So it's not an exceptional star, just another telescopic star out there in the Scorpius Centaur region of the night sky. J1407 is a young star that hasn't yet settled into its stable, long-duration phase. This is important because Super Saturn, officially J1407b, is showing signs of having a ring system in an early stage of development. Super Saturn's light curve was tucked away in the mountain of data from the Super WASP project. Professor Eric Mamajek and his associate Matthew Kenworthy of Leicester University studied the data thoroughly and produced a detailed report on it. Knowledge depends on good data. The horizontal axis of J1407b's light curve, the time axis, is what's causing all the hubbub. It took Super Saturn weeks to transit across in front of its parent star, 56 days to be exact. Planetary ring systems that we are familiar with in our solar system orbit right around the equators of the gas giant planets and are very thin, from only a few meters thick down to a few centimeters. In a telescope, Saturn's rings will seem to disappear when the planet is at 0 inclination toward Earth. Saturn must be inclined at an angle in relation to Earth to see Saturn's beautiful ring system. It's something everyone should make a point of seeing: Saturn in a telescope. If Super Saturn's rings block most of the light from J1407 for 56 days, it means that the planet had to be orbiting at a steep inclination to its star. If it were at 0 inclination, we wouldn't see the rings blocking any light. Therefore, the orbital time could be determined 10 years minimum to 200 years if the orbit is highly elliptical. The superplanet itself is calculated to be 24 times the mass of Jupiter, which means that if it is gaseous, it could be a brown dwarf star. Super Saturn appears to have a Mars-sized object orbiting around it, because there is a huge gap in the rings that was most probably cleared out by a large object. The Cassini division in the rings of Saturn is where the moon Mimas has cleared out a path through Saturn's rings. The light curve of Super Saturn has only been observed once. All the exoplanet detection systems are keeping an eye out for it to come back around J1407. No one knows when that will occur. Some astronomers have suggested that J1407b is a brown dwarf star system in itself, merely passing in front of, but not connected to, star J1407. An orbital reappearance of Super Saturn would disprove that conjecture. The center region of Super Saturn blocked out all the light from its primary star. This is what indicates that the ring system is new and in an early developmental phase. Over time, the very dense ring mass close to the planet is expected to thin as all this matter gets absorbed into the planet or ejected into space. This is what has happened with our solar system's gas giant planets. The Mamajek object is a shocker. Never before or since has a light curve been detected like Super Saturn's. Super Saturn has added a new chapter to our understanding of the formation of ring systems. So, here's to you, Super Saturn. Hope to see you again soon.
In our solar system, most planets spin counterclockwise, but not Venus. This rebel planet decided to spin clockwise, and scientists are still trying to figure out why. By the way, why do planets rotate in general? What defines the speed of their rotation? Does the sun rotate? Buckle up and let's try to answer these questions. Venus is the second planet from the Sun and the hottest planet in our solar system. Did you know that Venus is sometimes called Earth's twin? That's because it's similar in size and composition to our own planet. But that's where the similarities end, because Venus is a pretty crazy place, to say the least. For example, the weather. On Venus, it's always hot and cloudy. And when I say hot, I mean it like it's over 800 degrees Fahrenheit there. And those clouds, they're not made of water like the ones on Earth. Instead, they're made of sulfuric acid. So yeah, you wouldn't want to go outside without a really good sunscreen on Venus. If you look at the photos taken from its surface, you can see these toxic yellow clouds and cracked, desolate landscapes. And the spacecraft that captured this turned off almost immediately after sending these photos. Poor fella. But the surface of Venus isn't just some solid, dark, flat land. In fact, Venus has mountains that are taller than Mount Everest. These mountains aren't made of rock like the ones on Earth, though. Instead, they're made of a kind of volcanic material that's denser. Venus is a pretty creepy place that holds many mysteries. One of them has been puzzling scientists for years, and this is the planet's rotation. Most planets in our solar system rotate counterclockwise, but Venus isn't like the other girls. It rotates clockwise, and that's not all. It also rotates around the sun faster than it rotates around itself. In other words, a year on this planet passes faster than a day. It's almost like Venus made being quirky its life mission. But why is that? Well, scientists have a few theories. The most popular theory says that Venus was actually spinning counterclockwise like the other planets, but then something happened to flip it around. And what could that something be, you ask? A planet-sized object. Yep, astronomers believe that something huge once collided with Venus, causing it to spin in the opposite direction. You can imagine this like a cosmic billiard shot, with this mysterious huge object being the cue ball and Venus being the target ball. But we can't actually say that Venus is spinning the wrong way. There's no such thing as a wrong direction of spin in the universe. This is actually called the retrograde rotation. This is when a planet rotates in the opposite direction to its orbit around the Sun. Venus, for example, has a retrograde rotation, which means that the Sun rises in the west and sets in the east on that planet. So now when the horoscope says something like Mercury in retrograde, you'll know what it means. Oh, but Venus isn't the only weird one in our solar system. There are definitely some wacky ways that planets can rotate. For example, most planets in our solar system spin around an imaginary line called an axis. This axis is usually straight up and down in relation to the planet's orbit around the Sun. However, some planets like Uranus have a tilted axis, which means it's almost on its side in relation to its orbit. This tilt causes the planet's poles to be nearly in the same place as its orbit. The result? As the planet orbits the Sun, different parts of it receive different amounts of sunlight, causing extreme seasonal variations. For example, one pole might experience continuous sunlight, while the other is in complete darkness for a long time. Uranus is the only planet in our solar system that rotates on its side. Scientists think that it could repeat Venus's history. Once upon a time, a large impact knocked Uranus off its original axis of rotation, causing it to tilt at an angle of 98 degrees. We should be grateful for Jupiter. Its crazy gravity pulls all the asteroids and protects us from such collisions. All this is somewhat similar to tidally locked planets. Imagine going on a date with a planet, but instead of being charming and mysterious like you'd hoped, it's just staring at you with the same face all night long. That's basically what it's like to hang out with a tidally locked planet. Tidally locked planets are planets that rotate around their axis at the same rate that they orbit their star. This means that the same side of the planet always faces the star, while the other side is in permanent darkness. Being tidally locked can have some weird effects on the planet's climate and weather. The side facing the star can become extremely hot, while the other side can be incredibly cold. The atmosphere on the planet can also get pretty wild, with strong winds blowing from the hot side to the cold side. And it doesn't have to be planets only. Our moon also works this way. Did you know that we always see only one side of the moon? That's because it's tidally locked to the Earth. We can also take the dwarf planet Pluto as an example. It has a strange rotational relationship with its largest moon, Charon. They're tidally locked, which means that they always face each other with the same side. As a result, Pluto and Charon appear to waltz around a common center of gravity, creating a unique dance in space. But the oddities of our solar system don't end there. There are also planets with super fast rotations. While most planets rotate at a fairly sedate pace, some of them are sonic levels fast. Jupiter, for example, rotates once every 9 hours and 56 minutes, which means that it has a day that's less than 10 hours long. That's fast enough to cause the planet to bulge out at its equator. And also, this rapid rotation creates strong bands of winds that can reach speeds of up to 400 miles per hour. And if all this still seems logical and kinda makes sense, then how about chaotic rotations? Yep. Some planets have a rotation that's so irregular and unpredictable that it's known as chaotic rotation. This is often caused by the gravitational influence of nearby moons or other planets. And it's mostly the case with moons and small objects like that. In our solar system, some moons of Pluto, Saturn, and Neptune have chaotic rotation. By the way, the Sun rotates too, just like the planets. However, its rotation is not uniform. The equator rotates faster than the poles. Pretty weird, isn't it? This phenomenon creates a magnetic field that's responsible for phenomena like sunspots and solar flares. But all this raises an interesting topic. Why do planets rotate in the first place? This may sound like a silly question, but can you answer it? The answer might be trickier than you imagine. It all started around 4.5 billion years ago with the formation of our solar system. When it formed, it started as a large cloud of gas and dust. As the cloud began to contract due to its own gravity, it began to spin faster and faster, like a spinning top. This spinning motion caused the cloud to flatten into a disc-like shape. As the cloud continued to contract, the center became denser and hotter, eventually forming the Sun. Meanwhile, the material in the disk began to clump together and form planets. But because the disk was already spinning, this spinning motion was inherited by the planets as they formed. In other words, the planets rotate by inertia. They inherited the spinning motion of the cloud of gas and dust from which they formed. This is known as the conservation of angular momentum. This is the same principle that causes ice skaters to spin faster when they bring their arms in. And that's a wrap on the wacky world of planet rotations. From the lightning-fast spin of Jupiter to the bizarre backwards rotation of Venus, it's clear that our solar system is full of surprises. But thanks to the laws of physics and the gravitational pull of the Sun, these planets continue to spin on, keeping time with the steady beat of the cosmos. Stay tuned.
The Grand Canyon in Arizona is bigger than the state of Rhode Island. You could even fit the whole of Manhattan in there. It's so massive, it kind of has its own weather. But the Grand Canyon isn't the only big crack out there. The Valles Marineris is bigger, way bigger. It's on Mars, and it goes nearly a quarter of the way round the planet. It's 10 times as long as the Grand Canyon, and it's so deep, you could parachute into it. The Kesai Vallis is also on Mars. It's made up of a series of canyons, and it might be the ancient home of a massive Mars flood. There are huge canals and canyons all over the red planet. There's Tiu Vallis. That's where researchers think there was an epic battle between ancient Martian water and boiling hot volcanic lava. Guess we know who won that one. Equally impressive is Ares Vallis. It's the longest known drainage system around. It might be weird to think of Mars as having huge waterways, rivers, and floodplains, but in its early days, Mars might have had a warm and wet climate. Now it's just dried up canyons as far as the eye can see. The Ithaca Chasma looks like a giant scar on Saturn's moon Tethys. It's 4 times longer than the Grand Canyon and about 3 times as deep, and it's billions of years old. No one's been kayaking there yet. We've only seen a photo of it, thanks to the spacecraft Voyager 1. Mercury's Great Valley makes the Grand Canyon look like a tiny pothole. NASA's Messenger spacecraft was the first to snap some photos of this massive formation. The valley's surrounded by 2 giant somethings, the Enterprise and Belgica, whatever that means. Pluto's largest moon, Charon, has a canyon named Argo Chasma, and it's huge. Even though Pluto's not called a planet anymore, it can still brag about its huge canyon. Even right here on Earth, the Grand Canyon has some serious rivals. Yarlung Tsangpo Canyon is the deepest canyon on Earth. It's in the Himalayas, in Tibet. Some people call it the Everest of canyons. You could fit a 2,000-story building in it. The Indus River Gorge is big and gnarly. It's in Pakistan, and you could stack 3 football fields inside it. The Indus River, one of the largest rivers in Asia, passes through it, and it's even home to baleen whales and porpoises. The Colca Canyon in Peru is a short but insanely bumpy bus ride away from Machu Picchu. It's the massive home for the largest flying bird in the world, the Andean condor. It has a wingspan of 10 feet. In Nepal, where the Himalayas are, is the spectacular Kali Gandaki Gorge. No one knows exactly how far down it goes, but it's probably around 5 times as deep as the Grand Canyon. It's got it all: crazy terrain, thin air, and it's in the middle of nowhere. So beware, only experienced hikers should dare go in. The Copper Canyon in northern Mexico is home to a world-famous group of people who run marathons, or even double marathons, just for fun. There are 6 canyons all joined together, and in its widest part are 2 of Mexico's tallest waterfalls. Copper Canyon also has one of the longest zip lines in the world, and one of the scariest train rides you'll ever take. Don't look down. Even in the US, there's a lesser-known canyon that's deeper than the Grand Canyon. It's Hell's Canyon. And it's sort of on the border between Oregon and Idaho. It was carved out by the Snake River. Hell's Canyon is home to the Seven Devils mountain range. The Kings Canyon is in the Yosemite National Park area. It's about 1.5 times as deep as the Grand Canyon. Nearby is the second largest tree on Earth, General Grant. The largest canyon in Australia is the Capertee Canyon, and you can get paid to go there. Sort of. A few lucky cyclists and campers over the years have found gemstones on the banks of the Capertee River. If you're lucky, you'll also see some 2,000-year-old rock art. The Tiger Leaping Gorge is right out of a fairy tale, but it's very real, very deep, and pretty scary. The legend says that a tiger was being chased, and it leapt over the river at the bottom of the gorge, with a little help from a perfectly placed rock right in the middle of the river. The Great Rift Valley is 15 times longer than the Grand Canyon. So what, that's like 1 trillion miles long? It goes through 2 continents and is home to about 30 lakes. It's even visible from outer space. So if you're ever floating out there in the cosmos, keep an eye out for it. The Cotahuasi Canyon is deep, very deep. It has extreme rafting, kayaking, and hiking. And apparently the mosquitoes are pretty extreme too. There's one canyon in Tibet that I'm pretty sure holds a world record. Try looking up the Polong Tsangpo Canyon. No images pop up. It's 2021, that's insane. What's down there? Yeah, probably just a river and stuff. Colombia's Chicamaca Canyon is pretty much as deep as the Grand Canyon. Extreme sports own this place. Ziplining, canoeing, paragliding. Heck, even their cable car is extreme. It's a 25-minute ride, and it's steep. Under Greenland is the Greenland Grand Canyon, and it goes for hundreds and hundreds of miles. Water from melting icebergs runs through the canyon. It was actually NASA who discovered it. There's an absolutely massive canyon in Antarctica. The only problem? You can't see it. But apparently, it's freezing cold and mostly white. The sea has some mighty canyons too. The Jemchug Canyon is one of the biggest underwater canyons. It's right off the coast of Alaska, and it's home to seals, dolphins, and whales. The deepest underwater canyon is about 6 times as deep as the Grand Canyon. It's the famous Mariana Trench. Make it to the bottom, and you'll break the world record for deepest dive ever. The Grand Bahama Canyon is another underwater marvel. You could just keep dropping Empire State Buildings in there, and you'd never see them on the surface. Monterey Bay is pretty laid back, but its canyon is anything but. There's lanternfish, squid, sea turtles, rockfish, and sea otters all hanging out together. Oh, and thousands of jellyfish, so take care not to get stung too much. There's also giant kelp around there, a seaweed that can grow up to 100 feet long. The Hudson Canyon runs from the New York Harbor right into the sea, and it's gross. Sure, it has deep sea coral and sponge formations, but it also has a whole bunch of trash and sewagey sludge coating the bottom. The Aviles Canyon is off the coast of Spain. It's one of the deepest underwater canyons in the world, and it's one of the few places where giant squid live. It's famous for its white coral and the fact that it's insanely cold. Bremer Canyon in Australia is underwater, massive, and dangerous, especially if you're a giant squid. That's the favorite snack of the local orca, the huge whale with a monster appetite. Bremer Canyon's a major tourist destination these days, especially for those looking to snap a pic of the more than 100 orcas that call it home. The Nazare Canyon is near Portugal. It's the largest submarine canyon in Europe, and it's around 3 miles deep. That's 6 of the world's tallest buildings. It forms high breaking waves, so it's become a haven for big wave surfers. The Canadian Arctic Rift System is huge. It goes all the way from the Labrador Sea to the Arctic Archipelago. and it connects the Arctic and Atlantic Oceans. So, picture this. Greenland used to be smashed up against Canada some millions of years ago. Thanks to this rift system, Greenland's been slowly drifting away. Think how huge Canada would be if you added Greenland onto it.
The red, parched earth under your feet is shaking. Large cracks are opening in the ground, threatening to swallow you. But unlike on Earth, these quakes aren't coming from within the planet. A threat coming from space is triggering them. Scientists have made a shocking discovery about Mars quakes. By using AI and NASA's InSight data, they found out that some of those tremors are caused by meteorite impacts. It means that Mars gets hit 2.5 times more often than we thought, and new craters are forming all the time. But the scariest part is that these impacts don't just shake the ground. They send powerful shock waves deep into the planet, revealing a hidden seismic highway and an unstable interior, unlike anything we imagined. This changes everything we thought we knew about Mars. So now, the big question is, what else is lurking beneath the surface? But let's follow scientists' train of thought first. They took Marsquake data from NASA's InSight lander and compared it with fresh impact craters spotted by the Mars Reconnaissance Orbiter. That's when they discovered that some impacts create a seismic highway through the mantle instead of being absorbed by the crust. Even though NASA shut down InSight in 2022, its data is still precious. The lander, which placed a seismometer on Mars, recorded over 1,300 Marsquakes, some caused by underground rock cracking under heat and pressure, others, apparently, by meteoroids slamming into the surface of the red planet. By studying how seismic waves move through the crust, mantle, and core, scientists keep piecing together Mars's deep structure. In the past, researchers already linked impact craters with seismic data. But these new studies are the first time when a fresh impact has been connected to quakes detected in Cerberus fossae. That's a highly active region 1,000 miles away from InSight. Scientists have discovered this 71-foot-wide crater much farther from NASA's InSight lander than expected, if we consider the strength of the seismic waves it produced. Mars's crust was thought to absorb most of the energy from impacts, which would limit how far seismic waves could travel. But the analysis of this crater revealed that, instead of getting dampened, the waves took a more direct and deeper path through the planet's mantle. This unexpected finding suggests that Mars has a seismic highway, which allows quakes to spread much farther than previously believed. Now, the InSight team will need to reassess their models of Mars' internal composition and structure. And then, we might better understand how impact-generated seismic signals can reach such depths. Manually sorting through the vast amount of data would have taken years. But luckily, these days, there are new tools, and scientists can go from tens of thousands of images to just a few in a matter of days. So, researchers focused on finding craters within approximately 1,800 miles of InSight's location. Their aim was to identify those that formed while the lander's seismometer was active. By comparing before and after images from the context camera over time, they identified 123 fresh craters to cross-reference with InSight's seismic data. Out of those, 49 craters were potential matches for quakes detected by InSight's seismometer. And after conducting some more analysis, the team decided that the 71-foot Cerberus fossae impact crater was the main finding. This discovery is likely to help scientists differentiate between signals from internal quakes and those caused by meteoroid impacts. Initially, they believed that Cerberus fossae produced a lot of high-frequency seismic signals linked to quakes originating inside Mars. But the new data suggests that some of this activity may have been caused by impacts, not internal processes. Another mystery scientists haven't been able to crack for 50 years is why Mars is split into two very different halves. But thanks to recordings of Marsquakes, they may have finally found the answer. Since the 1970s, researchers have known that Mars has two distinct regions. The northern lowlands cover about 2/3 of the planet's northern hemisphere, and the southern highlands make up the rest. The southern highlands sit about 3 miles higher than the northern lowlands, and the crust, the planet's outer layer, like a shell, is thicker in the south. This strange divide is known as the Martian dichotomy. There are two potential explanations for this imbalance. One theory suggests that an unknown internal process within Mars created the difference. The other claims that a massive collision, probably with a moon-sized space rock or several smaller impacts, once reshaped the planet's surface. But Mars' surface is extremely old. That's why pinpointing exactly what happened has been difficult. But now, a new study, published on December 27, 2024, has used Mars-quake data from NASA's InSight lander to figure out whether the cause of this difference lies deep inside the planet. InSight was positioned near the boundary between the northern lowlands and southern highlands. Its mission included recording seismic data from Marsquakes, which travel through the planet's mantle, the rock layer beneath the crust. So scientists compared how these waves moved under both lowlands and highlands. They looked for differences in the planet's deep interior. It turns out that the seismic waves lost energy much faster when traveling through the southern highlands. It means that the mantle beneath this region is significantly hotter than in the north. It's compelling evidence that internal planetary forces, rather than an external impact, caused Mars' unusual split. The research team believes that the temperature difference between Mars' two halves can be traced back to ancient tectonic activity. It once shaped the planet, but later stopped. At some point in the past, Mars had moving tectonic plates, like Earth's. As these plates shifted, they, along with the molten rock beneath them, could have created the Martian dichotomy. But eventually, the movement stopped, leaving behind what scientists call a stagnant lid. That's a thick, immobile layer over the planet's molten interior. If this turns out to be true, it might mean that the mantle beneath the southern highlands is still pushing upward, while the mantle under the northern lowlands is sinking deeper toward the planet's core. This ongoing process could explain why Mars' crust is thicker in the south. At the same time, we can't completely rule out the idea that an external impact created the dichotomy. Some recent studies suggest that a giant collision could still be a possible explanation. To solve this mystery for good, scientists will need more Marsquake data and detailed models of how Mars originally formed. By the way, if you ever decide to visit Mars, you might come across the hero of our video today, the InSight lander itself. It was supposed to launch in March 2016, but a problem with one of its instruments caused a delay. It was a vacuum leak in the seismometer. NASA rescheduled the launch for May 2018, and the issue was fixed in the meantime. But this delay increased the total cost from $675 million to $830 million. Still, InSight successfully landed on Mars on November 26, 2018. But over time, dust built up on its solar panels, making it harder to recharge. The InSight lander runs on solar panels and batteries, but it needs occasional wind gusts, called cleaning events, to clear dust from the panels. Unfortunately, the place where InSight landed didn't get enough of these winds to keep the lander fully powered. By February 2021, during the Martian winter, thick dust had covered the panels, and they were only producing 27% of their full capacity. To save power, NASA started putting InSight into hibernation mode, shutting down instruments gradually to keep its electronics warm. They hoped better weather would allow the lander to recharge and wake up by July 2021. In May 2021, the team found a clever way to restore some power by using the lander's arm to move sand onto the panels, helping the wind clean off some of the dust. But eventually, InSight was only generating 1/10 of the power from the sunlight than it did right upon arrival. In July 2022, NASA put it in low power mode to keep detecting Marsquakes. The lander kept operating until December 2022. On December 20th, NASA announced that InSight had lost contact with Earth on December 15th, and the mission